Thank you for joining us and welcome to this virtual board meeting of the National Transportation Safety Board. I'm Robert Sumwalt and I'm honored to serve as the chairman of the NTSB. And joining us today are my colleagues on the board, Vice Chairman Bruce Landsberg, Member Jennifer Homedy, Member Michael Graham, and Member Tom Chapman. Today we meet in open session as required by the government and the Sunshine Act to consider the rapid descent into terrain of a chartered Sikorsky S-76B helicopter in Calabasas, California on the morning of January the 26th of last year. The flight departed John Wayne Airport, Orange County in Santa Ana, California, and was destined for the Camarillo Airport. Weather was cloudy with haze during the flight. And 37 minutes into the flight, the pilot initiated a climb with a gradual left turn to, as he told the air traffic controllers, to get above the layers. It was the beginning of a series of events that ended 2 minutes later with the tragic loss of the helicopter, its pilot, and all 8 passengers. On behalf of all of us at the NTSB, I'd like to offer our sincerest condolences to the families and friends of those who were lost in this tragic crash. Our purpose, our entire purpose for this investigation is to learn from this event so that we can keep others from going through what you have gone through. In every accident, we study the roles of the human, the machine, and the environment. And today, at the juncture of human and environment, we'll discuss the aspects that influence the pilot's decision-making. He was flying under visual flight rules, or VFR, which legally prohibited him from penetrating the clouds. However, as we've seen in so many accidents, this pilot continued his VFR flight into clouds, or, as we say, instrument meteorological conditions. Today, we will discuss whether the pilot faced any pressure to complete the flight, and if so, where those pressures originated. What were the expectations of the pilot under the company policy? Did he put pressure on himself? And what actions could he have taken to avoid flying into the clouds? We'll discuss the phenomenon of spatial disorientation, which is the powerful, misleading sensation that confuses pilots conducting a visual flight who loses visual reference, and what types of training can be effective in countering this effect. We'll also discuss the organizations involved, specifically Island Express, which operated the flight, and the Federal Aviation Administration, which regulated the accident flight under Part 135 of the Code of Federal Regulations. That's the section regulating on-demand charter flights like this flight. The NTSB has long recommended life-saving changes to Part 135 operations. In fact, improving the safety of Part 135 aviation is on our most wanted list of transportation safety improvements. We'll discuss whether any part of the Part 135 changes that we've recommended, if acted upon, could have changed the outcome of this flight. For example, the NTSB has repeatedly recommended that the FAA require Part 135 operations to have a safety management system, or SMS, but that at the present, the FAA does not require SMS in Part 135, despite our repeated calling for it. Now, I will say that Island Express did have an SMS, but today we'll discuss the company's implementation of its SMS and the differences between it and a mandatory SMS, which would have been subjected to FAA oversight. The FAA has also recommended that flight data monitoring programs and devices capable to enable FDM be mandated by the FAA in Part 135 operations. FDM is a flight data recording and analysis tool to help pilots, instructors, or operators improve performance and safety. Today, we'll discuss the benefits of FDM as it relates to an operation such as Island Express. And we'll also discuss whether information might be missing from our discussion, because this helicopter did not have a crash-resistant flight recorder system capable of recording audio and images. Such systems can show, for example, visual cues associated with the adverse weather, and the pilot's focus of attention in the cockpit. The NTSB has recommended that helicopter flights such as this one, the one we'll discuss, have such recorders. And this flight, this helicopter, did not have such a recorder. Now, each board member has studied the draft report, and each of us has met individually with the investigative staff. Today's board meeting, however, is the first time that we as a deliberative body will have gathered to discuss the report. Today, the staff will lay out the pertinent facts and analysis found in the draft report, and they will present draft findings, a probable cause, and recommendations to the board. And then we on the board will question the staff to ensure that the report that we adopt today truly provides the best opportunity to enhance safety. The public docket for this investigation contains more than 1,600 pages of additional relevant material, and it's available on our website at ntsb.gov. The report will also be available on our website in just a few weeks once any amendments voted upon today are incorporated and the report is finalized for release. At this time, I'd like for each of my colleagues on the board to introduce themselves. Vice Chairman Landsberg, good morning, sir.
Good morning, Mr. Chairman. Thank you. I'm looking forward to our discussions this morning.
It's great to see you. Member Hamady.
Little technical difficulty there. Hi, Jennifer Hamady, and good morning, Mr. Chairman. Good morning to my colleagues on the board and within the agency, and I look forward to the discussion.
Great seeing you. Member Graham.
Good morning, Mr. Chairman. I'm looking forward to our deliberations today. Thank you.
Thank you, Member Graham. And Member Chapman.
Good morning, Mr. Chairman and colleagues, and my thanks to our team for the excellent work done on this investigation.
Great. I'll now ask that Deputy Managing Director for Investigations, Brian Curtis, to introduce the investigative and support staff who will be participating in today's board meeting. Mr. Curtis.
Thank you and good morning, Chairman Sumwalt. I'd like to also thank everyone who helped make this virtual board meeting happen today. My only administrative announcement this morning is a reminder for the meeting participants to silence all their electronic devices at this time. Now I will introduce the staff for today's meeting. Unless otherwise noted, staff members are from the Office of Aviation Safety. Dana Schultz, the Director for the Office of Aviation Safety. Bill English, Investigator in Charge. Mike Richards, Meteorology. Fabian Salazar, Operational Factors. Dr. Dujuan Sevillian, Human Performance. Kathleen Silba, General Counsel for the NTSB. Darlene Hatchett, Director for the Office of Safety Recommendations and Communications. Jim Ritter, Director for the Office of Research and Engineering. Brian Soper, Air Traffic Control. Chris Babcock, Crash Resistant Flight Recorder Systems from the Office of Research and Engineering. Van McKenney, Airworthiness. Adam Hooray, Airworthiness. Nathan Hoyt, Safety Recommendations from the Office of Safety Recommendations and Communications. Greg Borsari, Helicopter Maintenance and Visuals. And Kathy Gagne, Report Writer. The presentations will begin with an investigation overview by the investigator in charge, Bill English. Mr. English.
Thank you, Mr. Curtis. Good morning, Mr. Chairman, Mr. Vice Chairman, and members of the board. On January 26, 2020, at 9:45 a.m. Pacific Standard Time, a Sikorsky S-76B helicopter, November 72 Echo X-ray, operated by Island Express Helicopters, collided with hilly terrain near the city of Calabasas, California. The pilot and 8 passengers were fatally injured, and the helicopter was destroyed by impact forces and fire. The helicopter was not equipped with a flight data or cockpit voice recorder, nor was it required to be. The flight was an on-demand charter, operated under the provisions of 14 Code of Federal Regulations, Part 135, to take the passengers from John Wayne Orange County Airport in Santa Ana, California, to the Camarillo, California Airport for a basketball tournament. The weather that morning included a widespread area of coastal clouds associated with a marine layer, a stable, humid air mass about 1,000 to 2,000 feet thick, often characterized by stratus clouds at its top and the potential for fog formation in some areas below. There were no hazardous conditions such as icing or thunderstorms. Mr. Richards will have further details on the meteorological factors in his presentation. The flight was operated with a single pilot under Visual Flight Rules, or VFR, as Island Express was not authorized to conduct passenger-carrying flights under Instrument Flight Rules. This is typical for helicopter charter operations. The pilot flying was Island Express's chief pilot, and he had been flying in the area for 10 years and had logged about 8,500 hours. Mr. Salazar will have further information about the pilot's pre-flight preparation and in-flight actions in his presentation. The flight departed at 9:07 and proceeded northwesterly across the Los Angeles metropolitan area. At 9:20, the pilot requested to transit the Burbank Class Charlie airspace, but ATC advised him to hold due to traffic. Weather in this area was reported as cloud ceilings 1,100 feet above ground level, with visibility 2.5 miles. About 11 minutes later, ATC provided special VFR clearance to proceed through the Burbank and Van Nuys airspace. Throughout this segment of flight, the helicopter was maintaining an altitude of about 500 feet above ground level. As the flight proceeded to the west out of the San Fernando Valley area, ATC advised the pilot that they would be too low for flight following, and they should contact Camarillo Tower as they got closer. The pilot acknowledged, and the helicopter proceeded to the west, following US Route 101 toward an area of rising terrain at a speed of about 140 knots. About 4 minutes later, the pilot contacted ATC again and advised them that he was intending to climb to go above the cloud layers. A surveillance camera near the 101 captured the helicopter about this time. The helicopter had been flying about 350 feet above ground level, but during the transmission to ATC began climbing at a rate of about 1,500 feet per minute, while generally following the 101 in a slight left turn. In this brief clip, you'll see the helicopter from the top right of the screen flying along the highway. During radio communications with ATC, the helicopter climbed through an altitude of 2,000 feet above sea level, or about 1,300 feet above ground level, by which point it was highly unlikely for the pilot to be able to maintain visual ground contact. The climb reached a maximum altitude of about 2,400 feet above sea level, as the helicopter continued a left turn diverging from the highway. The controller asked the pilot's intentions, and he said he was climbing to 4,000 feet. However, by that time, the helicopter was in a tightening left turn and descending rapidly. This maneuver is consistent with a pilot experiencing spatial disorientation in limited visibility conditions. Dr. Sevillian will have further details on this phenomena in his presentation. The helicopter impacted hilly terrain on a generally northeasterly bearing at a high speed and descent rate. Safety issues include continued VFR flight into instrument weather conditions due to self-induced pressure and planned continuation bias, leading to spatial disorientation due to physiological factors, including inner ear vestibular illusions. Staff has made recommendations regarding spatial disorientation training and simulation, as well as reiterated recommendations for safety management systems for Part 135 operators and flight data recording and monitoring programs for Part 135 operators. Mr. Richards will now present on meteorological factors.
Good morning. I will be discussing the weather surrounding the accident flight. At the time of the aircraft's departure, Orange County, Burbank, Van Nuys, and Camarillo were all reporting ceilings greater than 1,000 feet, and only Van Nuys was reporting a visibility less than 3 miles. Regional Terminal Aerodrome Forecasts, or TAFs, which provide weather forecasts for airports that were current at the time of departure, forecasted for the flight period ceilings at 1,000 feet or greater and visibilities of 3 miles or greater, except Van Nuys, which forecasted a visibility of 2 miles until 9:30 that morning. It should be noted that no TAFs were valid for the accident location. Airmets for IFR conditions and mountain obscuration were issued prior to the aircraft's departure and were active for the accident location at the accident time. Weather information for the accident time consistently presented an environment characterized by low clouds and restrictions to visibility. The image on the top left depicts hilltops near the accident site at elevations of about 1,400 feet obscured by cloud, and is compared with a clear day image below it. The image on the right is from a camera looking toward the accident location from a position about 2 miles east at an elevation of about 1,300 feet. This image was captured about the time of the accident and depicted relatively smooth and unbroken cloud tops at 2,400 to 2,500 feet. As Mr. English presented, a camera captured the aircraft moving toward the west and disappearing from view about 1 minute prior to the accident. About this time, an eyewitness on the ground below the aircraft's flight path witnessed the aircraft below or at the cloud line before it disappeared into heavy clouds that they described as a thick wall. Also about this time, the aircraft began its climb from an altitude of about 1,400 feet to about 2,300 feet. Though it was heard, no local cameras or eyewitnesses saw the aircraft during its climb. However, staff could not determine conclusively if the pilot would have been able to maintain intermittent ground contact at points between 1,400 and 2,000 feet. Above 2,000 feet, instrument meteorological conditions, or IMC, prevailed. Thank you. Mr. Salazar will continue with his presentation.
Good morning. I will brief you on operations. Island Express Helicopters was operating on an FAA-approved operations specification document that authorized the pilots to conduct on-demand, day and night, visual flight rules only flights. The company had 25 employees and operated 6 helicopters. Island Express was experienced in conducting charter flights. In 2019 alone, they flew 495 charter flights, many catering to high-profile clients. Island Express occasionally received flight requests from an air charter broker who used them exclusively for the accident client's local aviation transportation requests. The pilot was certificated, current, and qualified to fly in visual flight rules in accordance with federal regulations and company requirements. He had about 8,577 hours flying experience, which included about 1,250 hours in the Sikorsky S-76 series helicopter and about 75 hours of instrument flying time. There was no evidence of any pre-existing medical conditions and no evidence of acute or chronic sleep loss. After gaining employment with Island Express, the pilot completed all required company training, including Sikorsky S-76 ground and flight training, which contained modules for aeronautical decision-making and judgment, instrument procedures, unusual attitude flight, procedures for recovering from inadvertent entry into instrument meteorological conditions, and spatial disorientation. As the chief pilot, he held the responsibility of supervising and training all Island Express pilots. Upon advancement to check airman, he gained the additional responsibility of evaluating Sikorsky S-76 pilots during their annual proficiency and line checks. Island Express contracted with an outside training vendor that reinforced the ground and flight training using the company's helicopters. Per company policy, pilots were to fly no lower than 300 feet above ground level, with 500 to 1,000 feet above ground level recommended as a minimum altitude. Company policy identified 1 nautical mile as the minimum visibility when operating in uncontrolled airspace. These company minimums were more conservative than the Federal Aviation Regulation Part 135 helicopter altitude and visibility minimums. Company policy stated that all flights were to be accomplished in accordance with federal regulations and required pilots to obtain a weather briefing from the approved weather sources, and in the absence of that, by whatever sources are available. About 2 hours before his departure from the John Wayne Orange County Airport, the pilot completed a flight risk assessment that was consistent with weather forecast available at that time. The flight risk assessment fell into the low risk category and required no further actions. The pilot developed a plan to avoid forecasted clouds by flying east and north of downtown Los Angeles and filed a company flight plan. The company's FAA Principal Operations Inspector and the outside training vendor used similar standards for evaluating pilots performing actions after inadvertently entering instrument conditions. While wearing a view-limiting device and referencing the helicopter's instruments, the pilot was to level the fuselage and pitch and roll, maintain the current heading, turning only to avoid known obstacles, apply climb power of 70 to 75%, and adjust the pitch attitude to attain a climb airspeed of 75 to 80 knots. After these steps were accomplished, the aircraft would be in a stabilized climb, and the pilot would then contact air traffic control, declare an emergency, announce instrument conditions, and request vectors to visual flight rules, or if those conditions were unobtainable, request a precision instrument approach to an airport. After arriving over Highway 101, the pilot followed the highway towards Camarillo at an altitude of about 450 feet over rising terrain and maintained an airspeed of about 140 knots while advancing towards a cloud layer. About 2 seconds after entering the clouds, the pilot notified air traffic control that he was climbing to get above the cloud layers. The pilot had immediately begun a rapid climb of about 1,500 feet per minute while in a slight left bank, and remained in a left bank of increasing magnitude throughout the remainder of the flight. During the climb and subsequent descent, the pilot communicated with air traffic control on numerous occasions but did not declare an emergency. The excessive speed, entering the clouds, the rapid rate of climb, and the left turn were inconsistent with his training. This concludes my presentation. Dr. Sevillian will brief you on human performance issues.
Good morning. I will discuss the following human performance issues in this accident: pilot decision-making, spatial disorientation, and safety management systems. Several factors may have influenced the pilot to place pressure on himself to complete the flight. For example, the pilot was preferred and trusted by the client, as was Island Express. The pilot likely took pride in these positions of trust with both the client and with Island Express. The pilot had a good relationship with the client and likely did not want to disappoint him by not completing the flight. This kind of self-induced pressure can adversely affect pilot decision-making and judgment. Accidents involving self-induced pressure are not uncommon. However, there was no evidence that Island Express, the air charter broker, or the client placed pressure on the pilot to accept the charter flight request or complete the flight in adverse weather. The pilot's flight in IMC was inconsistent with his demonstrated judgment and decision-making observed by company management and pilots. When the flight began entering IMC, it was about 25 miles away from Camarillo, which was reporting VFR weather conditions. Although conditions were deteriorating en route, an alternative course of action was not acted upon by the pilot. The pilot's continuation of the flight, despite deteriorating weather conditions, was representative of planned continuation bias, which strengthens as the pilot gets closer to the destination. Devising an alternative plan before departure would have aided the accident pilot's decision-making in flight concerning whether to continue the flight as originally planned or divert and land at an alternate destination. The pilot's statement to the air traffic controller that he was initiating the climb occurred about 2 seconds after the helicopter entered the clouds. Data show the climb started at a rate of about 1,500 feet per minute, accompanied by a gradual left bank to the left, generally following the US 101. As the helicopter continued climbing into the cloud layer, the pilot's loss of visual references would have required him to transition to the flight instruments to maintain awareness of the helicopter's attitude and track. The inner ear senses balance and orientation. When flying an aircraft and there's a lack of outside visual references, our inner ear can give us a false sense of orientation because our inner ear cannot distinguish between accelerations and tilt. If a pilot cannot see outside visual references, he must rely on flight instruments. When there are no outside visual references, the pilot is more susceptible to inner ear illusions. One common illusion that can trick a pilot's perception into believing he is flying straight and level, but he is in a steady turn, is called the leans. During the climb in IMC, the helicopter entered a steady left turn conducive for the pilot to experience the leans. The vestibular system will usually detect initial rolling and turning movement. However, once the aircraft is stabilized in a steady rate of turn and angle of bank, the vestibular system will catch up with the aircraft, and the pilot can believe that the aircraft is straight and level when it is not. As the helicopter climbed, the air traffic controller asked the pilot to ident, which required the pilot to move his hand to the center of the instrument panel and press a button. The pilot's tasks associated with communicating with the controller and pushing the ident button introduced operational distractions from his primary task of monitoring the flight instruments. The resultant interruptions in the pilot's instrument scan, head, and hand movements would make him more vulnerable to misleading vestibular cues that could adversely affect his ability to effectively interpret the instruments and maintain control of the helicopter. The helicopter was in a left bank, rapid climb. Its bank increased, and it entered a tighter left turn that diverged away from US 101. The increasing bank would exacerbate the aspects of the leans. The resultant descent and acceleration were conducive for the pilot to experience a semi-graphic illusion, in which he would incorrectly perceive that the helicopter was climbing when it was descending. As the helicopter continued its steep descent, the pilot was either not referencing the helicopter's instruments or having difficulty interpreting or believing them due to the compelling vestibular illusions, and he did not successfully recover the helicopter. 2010 to 2019, the NTSB found that there were 184 fatal aircraft accidents related to spatial disorientation, 20 of which were fatal helicopter accidents. The NTSB has long recognized the value of cue-based and scenario-based pilot training to help reduce the risk of accidents involving continuation of flight under VFR into restricted visibility, a key risk factor for spatial disorientation. Simulation devices can provide representations of deteriorating weather conditions that cannot be realistically duplicated during flight training conducted in helicopters in VMC. This can help pilots safely practice decision-making skills and procedures needed to recognize and respond to changing weather conditions in flight. Staff has proposed a recommendation in this area. Effectiveness of spatial disorientation recognition and recovery training for helicopter pilots. The United States Helicopter Safety Team has established goals for promoting the wider use of spatial disorientation simulation technology. Increased use of this technology to supplement pilot training shows potential for helping pilots develop skills to detect and recover from vestibular illusions that could lead to spatial disorientation. Objective research to evaluate spatial disorientation simulation may help determine which applications are most effective for training pilots to recognize the onset of spatial disorientation and mitigate it. Staff has proposed a recommendation in this area. Company safety management system included safety policy, safety assurance, safety risk management, and safety promotion. The president of Island Express was aware of, but not involved with the SMS. The SMS was neither required by the FAA nor part of the company's FAA approved or accepted programs. And although the company used SMS tools, it did not implement the entire program and perform safety assurance evaluations, such as those that could have ensured the effectiveness of the flight risk analysis. The Director of Operations was the accountable executive and monitored flight risk analysis forms for necessary updates and followed up with pilots who forgot to submit forms for their flights. However, there was no evidence that company performed internal evaluation or hazard analysis using the information from completed forms as outlined in the SMS manual. Although the company had an SMS, our investigation showed that they did not effectively develop and implement the entire program. The NTSB has long advocated that the FAA require SMS for various Part 135 operations. Staff proposes reiterating a recommendation in this area. This concludes my presentation.
Thank you, Dr. Sevillian. Mr. Chairman, that concludes our presentations, and staff is prepared to answer any of your questions.
Thank you very much. I want to thank staff for those presentations. I also want to thank the staff for a very good investigation. We try to complete our investigations within about 12 months, and you've hit that mark. So thank you very much for that. We'll now turn to the board member questions, and we will do 5 minutes per board member, and we will do as many rounds as we need to. So Vice Chairman Landsberg, you're recognized.
Thank you, Mr. Chairman. I'd like to just make a statement. I'm really saddened by this crash, and we use the term crash rather than accident. And I think it's important to understand the distinction. An accident is something that is unforeseen, unpredictable, if you will. Unfortunately, this wasn't. We pretty well know what happened. We have a very good idea of why it happened, and we absolutely know how to prevent these kinds of crashes. And it's a leading cause of fatalities, as Dr. Sevillian has pointed out. We're averaging one helicopter crash of VFR into instrument conditions every 6 months for the last 10 years. So I guess the question I have to ask is, what part of cloud, when you're on a visual flight rules program, do pilots not understand? I'd like to start by asking a question here about the autopilot, because autopilots are not subject to spatial disorientation. Mr. English, how effective was the autopilot on the S-76B?
Yes, Mr. Vice Chairman, this particular helicopter was equipped with a very sophisticated autopilot called a 4Q or 4-axis autopilot. It is actually certified for instrument flight, so it can control pretty much every aspect of the helicopter control.
So it's absolutely capable of flying the helicopter without pilot input, is that correct?
The pilot has to set it up and tell it what to do, but it can certainly control the helicopter very well.
So it could be set on heading and pitch. So when the pilot, after he missed the opportunities to turn around, to land, to start executing a alternative plan, he could have, as he entered the instrument conditions, set the autopilot up so it would stabilize the aircraft and continue a climb up through the clouds. Is that correct?
The typical training that helicopter pilots are given, including this helicopter pilot, and we know this for a fact, their training for inadvertent IMC is to level the aircraft using the flight instruments manually. That's quicker. And then, as appropriate, engage the autopilot, as you mentioned, and command an altitude hold or a heading to or climb to then exit the conditions.
Is it difficult to activate the autopilot? Is it a major distraction, or is it fairly straightforward?
It does depend on exactly what he wants to do with the autopilot, which is why they level the aircraft first, so it doesn't do some unintended command on the helicopter. But it is a part of his training, and the behavior that we see, the turn, the rapid climb, the maneuvers that they made were not consistent with the IIMC training that this pilot received.
And I think it was made very clearly, they were getting regular training on these kinds of operations. Is that correct?
That's correct. This is a regular part of their yearly proficiency training.
You know, one of the things is, as I was reading up about this this crash, the U.S. Helicopter Safety Team and HAI, the Helicopter Association, have long come up with programs to deal with it. I think they had a program, still have, that's called Land and Live. And one of the things with helicopters is that you can put them down almost anywhere, a football field, something half the size of a football field, if necessary, unlike fixed wing where you need more space. In the training, did they have that kind of discussion?
As best we know, yes, they certainly did have that type of at least discussion in training. And it's also important for us to note that in this situation, this weather did not sneak up on the pilot very quickly. It was a condition that was very stable. So while you're absolutely correct, a helicopter can land in a very confined area, they also had a very easy alternative of landing at Van Nuys Airport, a large airport with lots of infrastructure just a few minutes away.
About how far behind them was Van Nuys? I'm assuming that's the closest one?
That was a close airport. It was roughly 10 to 12 miles behind them, depending on when they first started to encounter difficult conditions. So just a few minutes of flying time.
Excellent. Thank you, Mr. Chairman. I have more questions for later. Thank you.
Chairman, thank you very much. And Member Hamady.
Thank you very much. I want to start out first by addressing the family, friends, and loved ones of the 9 people who died in the crash. Not only as a safety professional for the NTSB, but I'm also a wife and a mother of a 13-year-old girl. So I can't imagine how difficult today must be for you, and of course every day since January 26, 2020. So my heart goes out to you. And I'll get into this later, but after today, today is just the beginning of the board's action to improve safety, improve aviation safety, and to ensure that a similar accident doesn't occur again. And we'll get into that a little bit more in the board meeting. But first, I also want to thank the staff for all their work, and in particular, Bill English, who is the investigator in charge for this investigation of the crash. Bill, if you can go ahead and turn on your camera. I have a couple of questions. First, you did not mention helicopter terrain awareness and warning system in your presentation. Can you talk about why not?
Yes, ma'am. Certainly, helicopter terrain awareness and warning system, or HTAWS, is one of a number of technologies that are installed in aircraft or can be installed in aircraft that aid the pilots in, just like it sounds, their awareness of terrain. These devices are designed for a class of accidents we call CFIT, or controlled flight into terrain, in which the aircraft, while under control of the pilot, generally either in instrument conditions or maybe night conditions or other difficult conditions, the pilot is not aware of the terrain. Maybe they turn the wrong way or descend below a prescribed altitude. The system, using GPS and a detailed database and other equipment such as radar altimeters in the aircraft, can warn the pilot that they are about to come up close to dangerous terrain. We do have recommendations, as you yourself have talked about, to install this on helicopters. However, this scenario of this accident is not consistent with a controlled flight into terrain scenario. This pilot had every indication that he was aware of the terrain along the Highway 101 as it was rising towards Calabasas. The radar and ADSB returns that we have on the helicopter show he was doing a very good job of maintaining altitude above the terrain. And in fact, his intent was to climb away from the terrain. So at no time was he ever in that type of danger in the early portions of the accident. He already was aware of the terrain somehow. In the final seconds, the rapid descent into the higher terrain where the accident site was, at that point, the aircraft is not in control, as Dr. Sevillian discussed. The pilot doesn't really know which way is up. So this type of system would not aid in that situation. It was beyond the parameters and would likely just be more of a confusing factor than anything else. So while it's great technology, we just don't think it applies here.
Thank you. And that's a great explanation. And let me ask you, you mentioned maintaining ground contact, helicopter operators and maintaining ground contact. And you mentioned him following the 101, and we had previously talked about him entering a slight left turn Many people I've seen have said, well, he was probably just trying to turn around, trying to escape the weather. Why do we know that is not the case? And could you talk about what we do mean about maintaining ground contact?
Yes, I'll make it quick. I see the time is running short, but we're talking about visual ground contact, not physical contact with the ground. Helicopter pilots typically navigate by, just like it sounds, looking outside, looking at the ground. In the time period that you're talking about, as the pilot was nearing this slight rise in the grade of the highway, we can see that the helicopter begins to climbing into the clouds and lower visibility conditions. Most likely looking straight ahead, the pilot would see nothing but gray into the cloud. But it's possible to see the highway and houses and things looking straight down. That's consistent with the path of the helicopter. The highway bends slightly to the left there, and the helicopter follows that bend. So we believe that this is consistent with the pilot doing just that, unconsciously setting up that left turn, which then leads to the situation which Dr. Sevillian described as the leans.
Thank you very much.
Member Hamidi, thank you very much. Great line of questioning. And Member Graham.
Thank you, Mr. Chairman. I've really struggled with this accident because I'm a career aviator, although a fixed wing aviator, not a helicopter pilot. But I've spent a lot of time with this accident and looking at how helicopter operations actually work. So I spent a lot of time looking at the industry associations out there working with safety of helicopter operations, and I pull a few things from there. And one of the very interesting things about they talk about in spatial disorientation on a lot of their safety bulletins is what's the best cure for spatial disorientation, and it's their number one advice is never get into it in the first place. So never get into the weather. So I want to go over a little bit about how to avoid inadvertent instrument meteorological conditions. And I took this right off the United States Helicopter Safety Team's website. And first of all, it's get a good forecast for departure, en route, and arrival. And we believe this pilot did get that. We're not exactly sure what he updated before he left the Santa Ana airport, but we believe he was well aware of that weather en route. The next thing it says is check the weather ahead of you en route, use ATC and flight watch during flying. So do we have any evidence that he was checking the weather or was aware the weather had changed from the forecast en route as he left Santa Ana and proceeded to the north?
Thank you, Mr. Graham, for that question, or Member Graham for that question. That is, it's hard to tell, but we do know one thing for sure, that he did obtain forecasts prior to departure. When he was approaching the Burbank and Van Nuys area, he did obtain the weather from the controllers in that area, which did show the current conditions of 2.5 miles visibility, which was actually somewhat less than forecast.
Okay. And he also, when he checked in with Burbank Tower, was he not updated on the weather, or should he have had an idea what the weather was? Because they told him it was what, IFR?
Correct. So either, I don't remember if it was that he tuned up the recorded weather or they just told him verbally, but yes, that's correct. The visibility was less than 3 miles in controlled airspace. So that considered IFR, at least for fixed wing aircraft. And that is slightly less than the forecast of 4 miles.
Okay, so he had some sense of what's going on there. The next thing about avoiding inadvertent IMC is avoid flight in marginal VFR weather. And we were already there, weren't we? As a matter of fact, we were below it there when he checked in with Burbank. He was actually below 1,003. He had 2.5 miles visibility. So didn't quite do that, but it's my understanding that this community will live with the lower minimums for the VFR only operations. Another advice to him is to plan en route decision points. Were we aware if he had any alternate plan or decision points along the way?
We're not aware of any of those.
We're not aware of any of those, yeah. The next thing it says is to recognize the signs. Deteriorating weather, obscured hills. Were there obscured hills en route?
Yes, there were.
There were, yeah. And other things would be fog. There was forecast fog. And what about visible precipitation? Was there any en route?
I don't believe there was visible precipitation. Mr. Richards might be able to clarify that for you.
Okay.
No, sir. No evidence of visible precipitation defined as hitting the ground.
Okay, thank you. Another recognized signs would be descent below planned altitude. I believe the operations recommended 500 feet AGL to 1,000 feet AGL. Had he gone below that?
That's correct on the recommendation. And as the flight proceeded westerly along the 101, the AGL altitude steadily decreased until about 350 feet when he initiated the climb.
Exactly. Okay. So again, it says assess the situation, and if signs back up the warnings, decide to land or turn around before you go into inadvertent IMC. Once you get into inadvertent IMC, you already talked about the training that he had from his training instructor and from his POI during check rides. The helicopter safety team points out, one of the things you need to do is the 4 C's: control, climb, course, and communicate. So you talked about controlling the aircraft, fly the aircraft, refocus the scan inside the cockpit to the primary flight instruments. That's airspeed, altitude, and attitude. Once you have that, climb. As soon as the aircraft is under control by referencing to the instruments, a controlled climb should be initiated. Inadvertent IMC encounters often occur at low altitudes where a rising terrain poses a serious threat. The pilot should initiate a straight ahead controlled climb to an altitude that will provide obstructive clearance in the area of operation. Did he climb straight ahead in that case when he penetrated the weather?
No, sir. The climb was initiated in a subtle left turn following the highway.
Subtle left turn. So he didn't follow his training. Do you feel he committed to the instruments in this case?
The path and behavior of the helicopter is not consistent with committing to the instruments.
Exactly. I agree with you wholeheartedly there. So, yeah, I'm just concerned about all this as a fellow aviator. He didn't even follow the training. So I see my time's about up. I would just say, as long as we continue to have VFR only helicopters continuing to flirt with marginal weather and sometimes submarginal weather, low altitudes, low ceilings, limited visibility, unfortunately, a certain percentage of them will stray into inadvertent IMC, and unfortunately, a certain percentage of them will not come out alive. Thank you, Mr. Chairman.
Great points, Member Graham, and thank you for those questions and comments. Member Chapman.
Thank you, Mr. Chairman. This was a tragic crash. The resulting loss of life is heartbreaking, and especially so with respect to the young people lost in the tragedy. I know I'm joined by my colleagues in seeking to ensure that some positive impact will result from the attention focused on this accident. The circumstances are painfully familiar to anyone with knowledge of trends in aviation safety. As we saw in the opening presentation from our investigative team, 184 fatal aircraft accidents occurring between 2010 and 2019 were related to spatial disorientation. 20 were fatal helicopter accidents. I am confident that many and perhaps most of these accidents involved pilots inadvertently flying into weather conditions for which they weren't prepared or equipped. As Member Graham pointed out very nicely, the lesson to be learned is for pilots to take this risk seriously, to adhere to their training, and to ensure they avoid the deadly risk posed by inadvertent flight into instrument weather conditions. To our investigative team, I know you're aware that I have a concern about identifying self-induced pressure as a contributing factor in the draft probable cause, which we'll consider at a later point in today's meeting. Certainly, it could be that self-induced pressure played a role, and it's reasonable to discuss it as a possibility, but there is little objective evidence on which to base the finding that it actually contributed to the pilot's decision-making. And to me, the conclusion seems speculative. Would you please elaborate on the findings of the investigation on this point?
Thank you, Member Chapman, for that line of questioning. Dr. Sevillian is prepared to respond to that question.
Thank you.
Yes, thank you. The objective evidence that we collected at Island Express was through interviews. And what those interviews let us know was that the relationship between the pilot and the client had turned into a friendship over the years, that the client allowed the pilot to fly his children without him being present. And that type of relationship that they had was very close. And when we look at human factor psychology, we look at the decisions that people make based off of the perception of a situation. And in this case, the pilot, as he was flying en route, this type of relationship that he had with the client can lead to self-induced pressure during the en route portion of the flight. And so that is why it's the objective evidence from the interviews that helped us understand that relationship and the effect that it can have on pilot decision making.
So the premise is that self-induced pressure can result when someone has a relationship of trust, in this case with a prominent person. There's a tendency to want to please that person so the relationship can be maintained. I do have a concern that we don't have much in the way of concrete indications that that was actually what occurred in this situation, but I do understand the basic premise. The investigation also indicates that the phenomenon of planned continuation bias was a factor contributing to the pilot's decision to continue the flight. Is planned continuation bias dependent on an element of self-induced pressure? So in other words, is it possible there could have been planned continuation bias without any self-induced pressure of the type that you've described?
Well, in this case, it was both self-induced pressure and planned continuation bias. And the planned continuation bias portion of it was the pilot continuing the flight despite changing conditions.
Are there other accident investigations? This is kind of an unfair question because I suspect you haven't prepared for it, but are there other accident investigations conducted by NTSB in which it's been found that self-induced pressure was a factor and that the presence of self-induced pressure resulted from a relationship with a prominent person?
I have, there is evidence that the NTSB has investigated accidents involving self-induced pressure.
Great, thank you. Thank you, Mr. Chairman. I see my time has expired.
Thank you, Member Chapman. Thank you very much. Yeah, it was per your last line of questioning, Member Chapman. I did notice that in our study that was done in 2005, risk factors associated with weather-related general aviation accidents, we did discuss in that the notion of planned continuation error or planned continuation bias. And so that's been prevalent in general aviation accidents. I know your question was more specific about the self-induced pressure, but planned continuation error is something certainly that we have seen in prior accidents. In fact, we define it as failure to revise the original plan when circumstances change, the type of error associated with poor in-flight decision-making and delayed remedial actions, types of accidents and incidents. I want to hit on something that has really, I've thought about for the last year. I remember right after the crash, one of the reporters covering it mentioned that the pilot may have been disoriented. And I think there's really two types of disorientation. There's the type of disorientation like you're lost. You might think you're over the I-5 freeway, but you're really over the 101. And that's not the type of disorientation that we're talking about here at all. We're talking about spatial disorientation, where literally the pilot may not know which way is up or down, whether he or she is leaning left or right. So I think it's important to draw that distinction. It's not like this crash, the pilot was just flying along, didn't know where the hills were, and blundered into the side of a hill. Do you agree with that, Mr. English? And I think that's consistent with the line of questioning that Member Hamidi was asking.
Yes, sir. The way you described it is exactly what we think.
And I too want to hammer the point that because this was a loss of control accident and not a control flight into terrain accident, that TAWS would not have prevented this crash. There's an article in the LA Times this morning that is talking about that. And I think a lot of people, including one of our former senior investigators, I read an article that he was quoted on on the anniversary of the crash, where he said he would expect the NTSB to issue a recommendation regarding TAWS. So I want to clear up that misconception there of the different types of disorientation. Mr. English, while I have you there, this aircraft was, in fact, it was IFR capable in terms of instrumentation. The aircraft itself was certified for IFR flight, but Island Express was not approved for IFR operations. Had they been so, what difference might that have made in this scenario?
Of course, would call for a little bit of speculation, but if you're asking about making this flight under IFR, for an appropriately certified IFR operation, this would not have been a difficult flight.
That's right, because instead of trying to scud run, and that's a term we use in aviation, instead of trying to stay under the clouds, you could have climbed up into the clouds and flown legally and safely if the pilot is properly trained and if the aircraft is properly maintained and certified for IFR. Is that correct?
Yes, sir, that's correct.
It would seem to me that if you are carrying passengers for charter, generally speaking, like this was a charter flight, it would seem to me that these flights should be operated under IFR. I realize that certain types of operations you cannot operate under an IFR clearance, such as logging or airborne law enforcement operations or sightseeing. But if you're carrying passengers for transport, it would seem safer that helicopter operations be approved for and operate under an IFR flight plan. We've seen numerous helicopter air ambulance crashes where the pilots are staying down low and they either run into something like ground or terrain or obstacles, or they climb up, they have an inadvertent IMC encounter. So I'm going to wrap it up here, but it would seem to me that that there would have been a business case for Island Express to have actually had their operation IFR certified. They canceled 150 flights in the previous year. And so anyway, I know we don't have a recommendation for this, but I believe that if flights could get up and fly in the clouds legally, there would be an increased safety margin. I'm out of time. Do you have any thoughts about that, Mr. English, given that I'm out of time?
I have nothing to add, sir.
Thank you very much. Vice Chairman Landsberg, we'll begin with you for the second round.
Thank you, Mr. Chairman. I'd like to explore that a little bit farther. Mr. Richards, I'd like to review a little bit more on the weather. So the forecasts at all of the weather reporting stations, we refer to them as TAFs, terminal area forecasts. How large an area around an airport does a TAF encompass?
So the forecast is valid, technically speaking, 5 statute miles from the center of the aerodrome. So we could say a radius of 5 statute miles around the airport.
So where the crash actually occurred, it was outside of the TAF area, is that correct?
Correct. It was significantly outside the closest TAF site, which would have been Van Nuys.
Okay. And there was also, I believe you referred to the term as AirMet. Could you explain the AirMet about IFR and mountain obscuration for some people who might not be familiar with that?
Sure. The AirMet is a product that's issued by the Aviation Weather Service National Weather Center. It's intended to advise pilots of potentially hazardous conditions in areas that they may fly. In this case, the National Weather Service had issued 2 AirMets. One was for IFR conditions, which in that context indicates ceilings less than 1,000 feet and or surface visibility less than 3 statute miles. And there was an AirMet issued for mountain obscuration, which is intended to convey that there is a threat of terrain in these areas may be obscured by cloud.
So in this case, it's also is it unusual that with the marine layer, as it comes in contact with the hills moving away from the ocean, that you would have the cloud layer coming down while the terrain is going up?
In a setup like this, it would not be, it wouldn't necessarily be a guarantee that you would find the low conditions at certain locations, but it would certainly not be a surprise. The ingredients are there for lower conditions, particularly in the area of variable terrain.
Is it possible that pilot reports might have helped, although I think most of the aircraft that would be departing from the airports might not be low enough in order for this to be evident? As you know, I happen to believe in pilot reports because what's forecast and what actually happens is sometimes a little bit different, and there's nothing better than having somebody look out the windshield and see what's going on.
Pilot reports are a very important source of weather information for pilots, both on frequency and then if they're collected by, say, air traffic controller. If they're disseminated long line, they're available across the world if someone needs to read those. Important.
I'd like to also talk just a little bit about the TAWS situation. We've already mentioned that TAWS wouldn't have helped, and we know that this helicopter was not equipped with TAWS. Mr. English, was the pilot using, or do we know that he had an electronic flight bag on board? And could you describe a little bit about that?
Yes, sir, Mr. Vice Chairman. The pilot typically used ForeFlight, which is a commercial electronic flight bag, works on an iPad, very popular amongst pilots. What that software does, running on the tablet, is charts, other information about airports, and it does include some other features such as it's rudimentary, it's not certified, but it does include a hazard advisory feature, depending on which level that you buy, that using the terrain, the chart database, and the GPS position that's fed into the iPad to aid the aware of surrounding terrain.
So I'm familiar with it because I use it myself, and it includes a terrain. It'll give you a terrain warning. You also have the option of synthetic vision. If you want to select that, it's merely a button push. And it also provides you with the weather conditions at all of the surrounding airports, which we know isn't necessarily helpful because we're outside of the TAF area. But I think the biggest thing we have to say on this is, again, the pilot is in the best position to see what's going on. He knew the terrain. He'd been flying in this area for a decade. He had over 8,000 hours, and he could look out the windshield and see that he was getting into instrument conditions and went contrary to all of his training. I'll stop here. Thank you, Mr. Chairman.
Vice Chairman, thank you very much. And Member Hamidi.
Thank you very much. My questions are probably going to be for Dr. Sevillian. The accident pilot completed a risk assessment form at 6:57 a.m. the morning of the flight, and at some point before departure, which I believe was at 9:07 a.m., there was a change in weather forecasted at Van Nuys. And I'm just going to read here. During the time the pilot was on the ground, weather information for Van Nuys included visibility of 2.5 miles, reported at 7:51 a.m. and again at 8:51 a.m., which was less than what had been forecasted. Island Express requires a new form when the weather changes. That did not occur. But what would have changed on the form if a new form had been completed with that information?
The flight, the risk assessment still would have been within the low risk category, and Mr. English could provide information on what would be changed in terms of
well, right. And just to add to that, my understanding is at that point he would have had to check special visual flight rules en route, correct?
Right.
Okay, so, and this is where I want to, and this may be you or it may be Mr. English. Feel free to pop up, Mr. English. On that one, if he completed the new risk assessment form and checked off special visual flight rules en route, it would have required an alternative plan to be developed. Is that correct? Now, I understand he would have had to go back and speak with the director of operations, who apparently said he trusted the accident pilot to make decisions based on his experience. And so that wouldn't have made a difference. But what would have made a difference is an alternative plan would have been filed.
Yes, ma'am. So let's unpack that a little bit. There's a couple things going on. The changes in the forecasts that we can see with hindsight, none of them would have triggered special VFR en route, other than one TAF period from Van Nuys, which it's questionable whether or not that actually even applied at the time that they would have planned to transit that airspace. But using worst case scenario, let's assume he got that forecast, checked special VFR en route. It's important to note, as Mr. Salazar brought up in his presentation, the VFR weather minimums for helicopters outside of controlled airspace is much lower than that. For fixed wing, helicopters are routinely flown in less than 3 miles visibility. And special VFR is simply and only applies in controlled airspace, such as Burbank or Van Nuys. It would require them to get a clearance to go through that airspace, but to fly in the same weather that they were already flying in until that point. So the mitigation or the alternative plan might be simply nothing more than obtain special VFR clearance, which helicopter pilots do routinely. But that's not as much of a red flag as far as weather as it is more of an air traffic delay and procedure type of thing, which we saw happened. They got a little bit of a delay due to air traffic.
I guess what I'm asking is, why wasn't there an alternative plan? An alternative plan could have helped. At the time at 8:37, he had a conversation with OC that mapped. He pointed to a map that said he planned to go north to Dodger Stadium in Los Angeles around Burbank and follow State Route 118. At some point after Van Nuys, he enters IMC around, and you and I discussed this, 9:44 and 45 seconds, sometime between there and 9:45 and 10 seconds. That's 35 seconds. I mean, that's not a lot of time. And so why wouldn't it have helped if you had an alternative plan in mind rather than a quick decision making?
Yes, ma'am. We're now moving past the special VFR area, and other than using that as just an indicator that things may not go exactly as you plan. In a global sense, and I may hand this to Dr. Sevillian, in a global sense, this is one of the things we found with the operator. They were not set up to have, we're not talking about weather alternates or things like that, but the alternative methods of getting the job done, the infrastructure there to help these pilots out if they do have to divert and assist the passengers in getting to where they're going, which those type of things can reduce the self-induced pressure that we've already discussed. And Dr. Sevillian, if we have a few more seconds, might be able to piggyback on that a little bit.
Yes, Island Express did not have any documentation or anything for that matter regarding alternative plans. So that wasn't available to the pilot.
Right, and I do want to get into that a little bit more in the next round of questioning on the risk analysis, this actual risk assessment form and SMS. So with that, I'm out of time.
Member Hamady, thank you very much. And Member Graham.
Thank you, Mr. Chairman. As you stated during the presentation, we've seen this accident before, unfortunately. Helicopters continuing VFR flight into instrument meteorological conditions, and unfortunately lose control of the aircraft due to spatial disorientation. In the last 7 or 8 years, what has the FAA or the industry done to try to eliminate this type of accident?
I think Dr. Sevillian has some background on some efforts in that area.
Thank you.
Yes, alongside the training that pilots take, there's a lot of guidance from industry associations regarding what a pilot should do if they get themselves into the situation. The United States Helicopter Safety Team has also worked on procedures and documentation to help pilots understand the risk associated with flying into instrument meteorological conditions. So there's a lot of effort there by the industry to help pilots in those circumstances.
Thank you. Yeah, they've done good work, like land and live programs. I know they push that. Some other things I've noticed that the FAA raised the minimum flight visibility for helicopters to a half mile, which is up from much lower, but it's still very limited visibility. I noticed air ambulance pilots, they've required them to hold instrument ratings, and also for the air ambulance helicopters to have the HTOS system. They've also required Part 135 helicopters to have radar altimeters and to be trained for inadvertent IMC, which this pilot and this aircraft actually have. But it looks like from the data that the statistics that this really hasn't helped a whole lot. As a matter of fact, we still average about 2 of these types of accidents a year, so it hasn't changed much. I'd like to switch over to instrument ratings. I know I'd like, at least for the fixed wing operators, probably don't understand instrument ratings as far as helicopters go. So is it, this pilot, I think we put out that he had about 75 hours of instrument time. Do we know if any of that time was in a actual simulator, or was it all simulated in the actual helicopter?
I don't know that we have it broken down that to that much granularity. Mr. Salazar can break it down as best we know.
Sir, we only have a resume or a documentation from Island Express that showed the 75 hours of instrument time, but it didn't break it out into simulator versus actual aircraft.
Okay. Did I actually see something that we might believe he only had 7 or less than 7 hours of actual instrument time?
There's no documentation that shows any of his actual instrument time, sir.
Okay. Okay. So we don't know. And actually, through my research, I found out, and this isn't the whole helicopter industry, but this is a vast majority of them have very little actual instrument time. A lot of them have very little simulated time in a simulator by being in a vision device, in reduced vision of device in an actual helicopter. So I know there are some instrument pilots out there in helicopters that actually have no actual instrument time, which is hard for a fixed wing pilot to believe, but that's not very conducive for good training and good instrument time. Is instrument flying a perishable skill?
Absolutely.
Yeah,
yes, sir.
It is. And do we know if this pilot was actually instrument current?
We do not have documentation to support that he was instrument current.
Yeah, and I think we find in much of this VFR only operations that many of the pilots are not instrument current. So, and an instrument flying being a perishable skill, once you do enter an inadvertent IMC situation, it'd be very, very difficult to transition to your instruments and trust them if you're not current on them. And I see my time's up, so thank you very much.
Member Graham, thank you very much. Member Chapman.
Thank you, Mr. Chairman. I have some questions about safety management systems. In 2016, NTSB recommended to FAA that all Part 135 operators should be required to implement safety management systems. Since then, the original recommendation to FAA has been reiterated by NTSB 4 times, each time based on our findings from investigations and other fatal accidents involving Part 135 operators that did not have a fully implemented safety management system subject to FAA oversight. Today, it's likely we will again reiterate the recommendation to FAA. This would be for a 5th time, and essentially this is 5 years after the initial recommendation. Apparently, there are some indications that FAA is considering action on this, but it appears to be a longer-term initiative for the agency. Is that correct? And how confident are we that FAA will eventually act on the recommendation?
I think Dr. Sevillian has been tracking the SMS process and can answer that for you, sir.
Mr. Hoyt, who's in recommendations, can provide an update on the current situation.
Thank you.
So in the fall of 2020, during the FAA's rotorcraft safety conference, the FAA administrators said that they were hoping to publish a proposed SMS rule in 2022 that would apply to air taxis, air tour operators, and others. It's also on OMB's fall 2020 unified agenda of regulatory and deregulatory actions, listed as a long-term action item. So it's looking like the FAA is making some progress, but there's nothing. We still don't have an NPRM or a final rule out.
So some encouraging signs, but certainly not imminent. This next question, I'm not sure who is best equipped to answer it. This has to do with the effort underway in anticipation of our most wanted list. You all are aware that work is underway in preparation for the adoption of the NTSB's 2021-2022 most wanted list. And I see that requiring safety management systems in all commercial aviation operations is among the issues under consideration. Am I correct that the primary audience for that proposed most wanted list item would be industry, associations, and operators, and not the FAA? Whoever can speak to that best, I appreciate an answer.
Yeah, I think, again, that would be Mr. Hoyt's area.
Yes, if you could repeat your question one more time, I'm sorry.
Yeah, it has to do with the work that's underway on the next version of our most wanted list. The proposal to focus on safety management systems for all commercial operators, that effort appears to me, from the materials provided to us, that appears to be focused on essentially on industry adoption of safety management systems, not on FAA taking action to require safety management systems. Is that correct?
Well, it would be both. I mean, we're wanting to reach out to industry so that they can voluntarily adopt, implement an SMS program, but we're also still wanting the FAA to require that.
So obviously we're sticking to our guns in terms of pressing FAA, but it sounds like we have more hope of progress when it comes to encouraging the industry to take voluntary action.
Correct.
Today, I don't anticipate that we'll make any broad recommendations to industry regarding adoption of safety management systems. Are we missing an opportunity to do so?
We have recommendations out to industry and specific operators as a result of previous investigations. So I believe staff feels that those are adequate.
Okay, so you're comfortable that essentially we're not passing up a good opportunity today, that we already have enough out there in terms of solid recommendations that we can build on.
Correct.
Thank you, Mr. Chairman. I see my time's expired.
Member Chapman, thank you very much. I want to follow up to something that Member Graham brought up, and I was looking in the draft report, as Mr. Salazar said, and Mr. Salazar, I think this would be for you. It does indicate that he had around 75 hours of, 75 hours of instrument flying time, of which 68 hours were flying under simulated instrument conditions. And so apparently he did not have a lot of hard actual instrument time. Can you explain, and you're a very experienced helicopter pilot. I know we don't like to speak about ourselves, but how many hours do you have in helicopters?
About 6,500, sir.
I'd say that's pretty darn experienced. And so can you describe what just flying under the hood, if you will, with a view restricting device, how would that be different than just flying along and all of a sudden entering clouds somewhat unexpectedly? How would that differ for a pilot's performance?
View limiting devices are good training aids for flying instruments, but they do give the pilot the ability to look around them. And as it's stated, one peak is worth 1,000 cross checks. Going to flying actual instruments, there's no cheating the system by looking over a set of view limiting devices. You're committed to the instrument conditions, which forces you to commit to the actual flight instruments.
Thank you. And would you would you agree that there might be somewhat of an element of surprise if you're flying under a view limiting device, then you've had time to acclimate to your instrument scan versus if you're flying visually and all of a sudden you encounter instrument conditions? Could there be somewhat of a element of surprise associated with that, which would potentially also affect your performance?
Yes, sir. Being prepared for the instrument conditions is part of the secret to success of flying instruments. When it's a surprise and you're unprepared for it is when unfortunate bad things happen or have the possibility.
Thank you very much. I'm not sure exactly who this question would be directed towards, but the FAA's literature on aeronautical decision making points out the importance of making the proper no-go decision, because if you make the wrong no-go decision, then you have the possibility of introducing more errors, more significant errors downstream. So making the proper no-go decision is critical. So based on the weather information that was available to the pilot at the time that he departed, was it an appropriate decision to begin that flight?
Mr. Chairman, even with the hindsight that we have of the weather conditions and knowing what was available to the pilot, we don't see that the weather conditions were such that should have necessarily affected the initiation of the flight. Having said that, your point about the error chain is exactly correct as far as in-flight aeronautical decision making. As things cropped up along the flight that were indicating that things were not as good as maybe they would have hoped, that should have started the aeronautical decision-making process going and to make a different plan. But there's nothing there that should have said no go.
Great, thank you. And just looking at it, I mean, the lowest visibility was 2.5 miles and the company minimums were 1 mile. So based on what he knew at the time, that does not appear to be an inappropriate go decision.
That's correct, sir. The conditions that we see, even up until the accident site, were at no point below the minimums for a helicopter. It was the in-flight decisions, the pressing on at high speed, that was where the ADM breakdown occurred.
Thank you very much. So quickly, I don't have a lot of time. There was an article in Bloomberg this morning that said that there were really two things that some experts had said could improve helicopter safety, one of which I've already hit on, was the requirement for flights to be conducted under an instrument flight plan, and the other was involving two pilots. And what safety advantages might we have gotten from if we had two pilots? I realize the helicopter was certified for single pilot operation, but are there any benefits that we might get from two pilots?
You're correct, sir. This operation was certified for two pilots. Dr. Sevillian has looked into the particular issues that would key a two pilot versus one pilot safety factor.
Well, thanks. And I realize I'm out of time, but I'd like, if my colleagues would indulge me, I'd like to just continue this line of questioning, and then we'll take a break after that. But go right ahead, Dr. Sevillian. Appreciate it. I'd love to hear your viewpoint.
Yes, there are benefits of having two pilots cross-checking one another. There's communication with another pilot. But again, there are also safety aspects that we have to consider here, is that there's always going to be a possibility of miscommunication with two pilots from that standpoint. But there's also workload implications just having one pilot.
So in other words, if you had two pilots, one could have assisted if this one pilot had spatial disorientation. The other pilot could have helped to monitor and correct the situation. Is that correct?
Yes.
I think it's interesting that this helicopter, this exact same helicopter, when it was operated by its previous owner, they operated it exclusively, I believe, with two pilots. And also Chevron Oil had conducted a safety audit, and Chevron was approved to use this particular helicopter with Island Express if it had one pilot or two pilots. Which was it?
Mr. English could give you an update.
It was two pilots. Two pilots. Is that correct, Mr. English?
Yes, sir. Chevron, as is typical of the offshore oil rigs, requested two pilots for this type of operation. And what we're saying is not that it's unsafe, but we don't have indications of those type of workload issues in this accident. And as far as, two pilots in the cockpit, we have Spatial D accidents with two pilots in the cockpit as well.
Well, I wouldn't really agree with that. I think that two pilots would increase the safety level. I flew with two pilots for a long time in an airline environment, and I think that you do get the redundancy that if you had one pilot who was struggling with flying the controls, the other pilot would be able to sit back and say, "Wait a minute, you're banking 30 degrees to the left. Now you're starting a descent." So I don't want to discount at all the importance of two pilots, and so I think a line of questioning that we'll ask that we might start later is, how does the consumer make a discriminating choice on what he or she is hiring? So we're going to take a break. Before we go into the break, I'd like to invite all participants to mute their cameras and their cameras and their microphones. We will take a break and we will reconvene at 11:10, and we are in recess. We are back in session, and we'll begin with the next round of questions. Vice Chairman Landsberg.
Thank you, Mr. Chairman. I'd like to follow up on your point on the sudden encounter with IMC conditions. This is perhaps for Mr. Richards. Is it your belief that the pilot had no forewarning that he was going to encounter lowering conditions here?
I'm not sure I can answer that question. Perhaps that's a question for Mr. English or Mr. Salazar.
Fair enough.
Yes, sir. I don't know that we could really say sudden in this case. The marine layer, as Mr. Richards did describe, was widespread, was in that area. It was lowering slightly as you worked your way to the west towards that higher terrain, and the terrain was rising slightly. But this was certainly something that could be seen by the pilot and anticipated. The high speed at which he was headed down the highway, that 140 knots, certainly didn't help any in avoiding it. But this is not the type of situation of a surprise type of squall line popping up or that type of thing.
Mr. Richards?
Yeah, I might add, this might help answer your question. I don't expect that the conditions around the accident site had changed much over the previous hour or two. So relative to the ground there, I would say conditions were relatively consistent.
And did we see on the radar that his altitude was decreasing as he got closer to the rising terrain? Was he envisioning that the cloud layer was getting a little bit lower and he was getting squeezed?
I think getting squeezed is a good description. We can see as they're heading westbound from the Van Nuys area and along somewhat flatter terrain, they maintain the 500 feet above ground level pretty well. The terrain starts to rise, the helicopter starts to climb, but after a certain point, he's not climbing anymore to maintain that 500 feet. And it starts to slowly tick down until we get to about that 350 that I mentioned, about where that construction site camera saw him.
So it would be reasonable to assume, I know that's a dangerous term, but it would be reasonable to assume that he had a sense, this isn't working as well as we would have hoped, and I'm having to kind of work at this to stay visual, and yet I'm losing terrain clearance. Is that a fair statement?
I think that's consistent with the data that we have, including his call to ATC and everything as well. That's all consistent.
Right. The chairman also talked about go versus no go. And there's only one time, I think, that you can make that, and that is prior to departure. Because once you've decided to go, now you've moved into a different decision-making realm. And so now it's constantly, you're having to assess, in this case, a mile or a mile and a half at a time, whether continuing is the right thing to do or whether we should be looking at some alternative. Does that make sense?
Yes, sir. That's entirely appropriate. It's actually discussed in ADM literature and training as well.
So moving from this, and again, Member Graham, I think, had talked a little bit. I'm a big proponent of simulation as opposed to going into the aircraft, but particularly when you're trying to do spatial disorientation, we don't get the full sense of vestibular disturbances without having some external motion in the process. And motion visual simulators are pretty good at that, but they're still not the aircraft itself. And having done a lot of training, both simulated and in simulators, both, where do we stand in terms of better in-cockpit simulation, such as a virtual reality helmet or something like that? Maybe Mr. or Dr. Sevillian could talk a little about that.
Yes, the United States Helicopter Safety Team is aware of technology, virtual reality technology used for helmets that can assist pilots with recognition and recovery methods. And so that technology is in the process of being developed.
So, and I guess I'm less concerned so much about the transitional aspect. That's nice, that's icing on the cake, but it would really be nice if we could just get really good IMC duplication exterior to the aircraft and not be able to use that one peak being worth 1,000 cross checks. My time is up, so I'll stop here. Thank you, Mr. Chairman.
Vice Chairman, thank you very much. And we'll now go to Member Homendy.
Thank you very much. Dr. Sevillian, I do want to talk about SMS and the risk assessment form that Island Express used. But first, there are probably a lot of people watching thinking, well, this was a, pilot issue. Why look at all the other issues with the operator? Why recommend SMS? Why look at a risk assessment form? Why look at cockpit voice recorders, flight data monitoring? Why do we go broader?
Because we want to ensure that we have an effective overall investigation and that we are looking into the details in all aspects. Like you noted, safety management systems involves the company, and we do look at company organizational factors.
Thank you. And with that, you mentioned 4 areas of safety management systems: safety policy, safety assurance, risk management, safety promotion, which were in the company's materials. Was it carried out that way?
No, it wasn't.
Yeah, and so typically you would have a top-down approach to safety management systems. That's what we often talk about. And while the director of operations was the account executive or on record, it is the president's role to really drive that home. And do you believe the president was really involved with SMS?
The evidence suggests from the interviews that we conducted that the president was aware of, but not involved in the company SMS.
And should be, though.
Absolutely, because it starts at the top of the organization.
Yeah, in fact, he said, my role is president, so at the end of the day, it all stops with me. But then he says, I'm not in the day-to-day operation at Island. And then when asked about SMS, he said, I wouldn't say I'm involved with safety management systems. I'm aware of it and how it's structured. And so it was clear to me throughout every single one of the interviews that the pilots, the director of operations, the director of safety, even the president thought their SMS program was essentially a risk assessment form, a tool that they had essentially contracted with outside vendor. Is that correct?
Yes, they did not ensure that a specific area, safety assurance, was integrated effectively into their SMS.
Yeah, so essentially all they talked about was this risk management, this risk assessment form. We have a copy of the form in the docket, and I looked at the form and completed it myself as if I was at that point at 9:45 on that pilot. And I checked off cloud ceiling, less than 2,000. Even if it was 1,000, you wouldn't get that many more points. I checked off special visual flight rules, 8 points. I even checked off light rain, which there was mist, but I gave him that. Visibility under 3 statute miles, familiar with the airport. Higher than 2,000 hours, estimated flight time 3 to 4 hours. Even added internal stress, self-induced stress. After I completed all of that and added it up, I came up with 37. What is their, how do they operate on these scores? There's a 45 and a 60. What do those scores mean to the company?
Yes, 45 would mean that the overall risk assessment is elevated, and 60 would mean that that would be a high risk, and they would have to seek management approval for mitigation.
So I got a 37, and that's really checking everything. So did anybody ever report getting to 60?
No.
Is that a problem? Do you see that as an essential That's a little bit part of the problem. The overall problem is actually the SMS program.
The SMS program, the SMS was the area that we identified, in particular, the safety assurance component, where we saw the issues.
And I don't have much time, but Member Graham asked about this. There is a voluntary program. Why do we recommend that it be mandatory? And how many operators actually participate in the voluntary program versus how many are out there?
The benefit of the FAA Safety Management System voluntary program is that the FAA FSDO, or Flight Standards District Office, can help work with the operator to set up their safety management system. And because the FAA has experience with developing SMS, that can aid the operator in understanding what's required. Currently, there are 17 operators, 135 operators that are in the process of or have been approved for the voluntary program, and another 158 that are in some sort of the process with the FAA of getting approval. So if you take the over, let's say, 1,900 operators, that's how that data is broken down.
So very few out of total operators are actually approved through the voluntary program to have SMS.
Yes.
So thank you very much. I'm out of time, and I will come back to this. Thank you for the additional time to allow him to answer my question.
Absolutely, and thank you for your questions. Member Graham.
Thank you, Mr. Chairman. I want to pick up right where Member Hamady left off, because I'm looking at that flight risk assessment form also, and I've worked with these in my prior flight operations, and I'm not a big fan of just numbered ones, because there may be a hazard out there that requires you to mitigate that risk, even though you don't get a 45 or 60 that would require some other kind of action. And if this pilot would have updated his flight risk assessment form when he was checking the weather at John Wayne Airport in Santa Ana, a couple things that jump out at me. He would have noticed the ceiling was lower than what was forecast that he originally looked at earlier in the morning. So he probably would have checked off two things. One would have been special VFR en route, which there's a caution there on the flight risk assessment form, says write your plan B in the header comments. So he would have required a header, a plan, an alternate plan. And then the other one was ceiling less than 500 feet, must call director of operations or chief pilot, which was him, but he should have called the director of ops and assess the weather and make a safety decision, which I would assume he would have talked about plan B. So in that case, that didn't happen, and it was unfortunate. So I'd like to jump back to where the vice chairman was talking about the pinch. And so Mr. English, you might want to come on up for this. As the pilot intercepted the 101 again and started heading up through the valley there, what was his airspeed? Had he changed his airspeed from what he was originally at?
No, sir. The airspeed was about 140 knots.
140 knots. Yeah. Okay. And in accordance with the FAA guidance and the training he had received from the Euro safety instructors, he was kind of getting pinched below maybe a little bit of lowering of the weather, and the terrain was coming up. I think we probably see data that he was very aware of that. What was he trained to do at that point?
It's very clear that slowing down is
slowing down.
Is part of this.
Yet he kept going at 140. Would it be uncommon for a pilot at that point, when he most likely entered the weather, we believe, and decided to climb, would it be uncommon for a pilot to trade that airspeed for altitude?
That's not consistent with the training, but
Correct.
That is what we look like. It looks like what he did.
Yeah. As a fixed wing pilot, that's what I would have done, but I wouldn't have been down there as a fixed wing pilot, most likely. So exactly, he didn't follow the training there. And a matter of fact, his POI, what did he tell the pilots about avoiding adverse weather? Do you know offhand?
Mr. Salazar is very conversant in the training.
Okay.
Would you repeat the question, sir?
Yeah. So what was he trained to do from the POI, or what did the POI advise him during his flights with him?
The POI would start with the on oral evaluation and seek information for an understanding that the pilot would avoid the instrument conditions. And then when he got into the aircraft, he would be required to perform maneuvers, unusual attitudes, and recovering from inadvertent entry into instrument meteorological conditions.
Yeah. Yeah. And I think one of the quotes out of there in the interviews, he said, pilot, to avoid adverse weather, he should divert, return to base, or land the helicopter.
Yes,
from the POI. And unfortunately, the pilot didn't do that in this case. So as my time's running out here, I think I would just like to echo what the chairman has said. And if I was looking to charter an aircraft for, to take passengers somewhere, or if I actually coordinated that for individuals to take a flight, I think I would really, in lieu of anything else that might come along from the FAA as far as regulation or anything, which obviously usually takes years to institute, I would hope that those chartering helicopters for passenger flights would look at IFR operators that have current and certified instrument pilots and are certified for IFR flight operations to transport my passengers. So with that, I see my time is up, and I yield back to you, Mr. Chairman.
Member Graham, thank you very much. And Member Chapman.
Thank you, Mr. Chairman. A question about an alternative plan. In draft finding number 7, which we'll look at in just a little bit, draft finding number 7 identifies 3 factors that apparently contributed to the pilot's decision to continue the flight, including lack of an alternative plan. However, lack of an alternative plan is not included or referenced as a contributing factor in the draft probable cause. Why is that? And should we consider referencing lack of an alternative plan as a contributing factor in the probable cause?
Member Chapman, perhaps I can expand on that a little bit. We may be thinking of alternative plan in the alternate airport rules or something like that from instrument flying, and that's not exactly what the main risk of that is here. The alternative plan keys into the self-induced pressure and the other biases that that we've been looking at, in that the company didn't really have a robust infrastructure to help out in case the pilot did have to go to a plan B, whatever that might be. Divert, for example, divert to Van Nuys. In fact, that was a relatively easy plan B. Divert to Van Nuys, if they waited 20 or 30 minutes there, the clouds would have lifted and easy to go through, or divert and get ground transportation. It wasn't very easy for him to say, this is something that we can do and it's not going to be a big deal. We think that is part and parcel of where we're talking about the company and their assurance and their oversight and being able to have some of these, not necessarily aviation alternates, but alternates that help take the pressure off the pilot.
Thank you, Mr. English. That's helpful. Actually, this will be my last question, Mr. Chairman, and it's not really a question. I want to return to the topic of voluntary safety management systems, and I want to reiterate the numbers that we just heard a few minutes ago. This is information that our investigative team obtained from the FAA. So FAA is aware of these numbers. There are 1,940 Part 135 certificate holders. Of those, only 17, as we just heard, only 17 have an FAA accepted voluntary safety management system. There are another 158 operators whose safety management systems are in various stages of development, and they've applied for FAA acceptance under the voluntary program, but they have a ways to go. So the level of participation on a voluntary basis among Part 135 operators is thin. It's laudable that some have taken the steps necessary to secure FAA acceptance under the voluntary program, but the numbers suggest there is a lot of work to be done. I hope FAA will eventually step up here. In the meantime, I encourage the various industry organizations and major operators which support voluntary adoption of safety management systems to maintain their efforts. My thanks to everybody today for the patience and good work during the meeting.
Member Chapman, thank you very much. Mr. Salazar, I want to return to a question that I was asking before the break. I got a little pinched on time there. As a very experienced helicopter pilot, can you tell me how having a second pilot might have helped in this situation?
Well, you have the ability to converse with the other pilot and share your thoughts on an upcoming decision. And if you make a decision that is questionable, the other pilot would be able to bring up concerns.
Thank you very much. So my question is, and I don't think there's an answer for this, it's curious that one of the clients for Island Express required 2 pilots, but not for all clients. I realize there's a difference between, I mean, this helicopter was certainly certified for single pilot operations, but there's a difference between legal and safe. And it's just curious to me why Island Express was not utilizing this helicopter in a 2-pilot configuration. Any thoughts on that? I don't think we know the answer. I saw nothing about that. Any thoughts?
I agree with you, sir. That's a hard question to answer.
Well, let me ask you this. How can a potential customer be assured or have the greatest knowledge about what he or she is getting? I mean, you know, we've mentioned a couple of things today that maybe, and Michael Graham, Member Graham, thank you for supporting this idea that it's good. It would probably be preferable to have an IFR capable charter operator. I've been trying to go along the line of questionings that 2 pilots might have been be a better operation. So how can the consumer be discriminating in terms of making sure that he or she is getting the absolute highest levels of safety?
Sir, that's something that we've been discussing with charters for many years. I go way back to the famous Platinum Jet accident, which we discussed this with Part 135. And we want to make it certain here that we are not in any way concluding in this investigation that Island Express was not a safe operator. This operation that they conducted, this flight, was entirely legal and is actually the norm for Part 135 passenger carrying helicopter operations. The vast majority of helicopter passengers operations are VFR and can be conducted completely safely. I think if the FAA didn't believe that, there would certainly not be so many of them. Can be conducted perfectly safely when conducted within the parameters of the regulations and their operation specifications. We're looking at a flight here that pressed on into the clouds, and we don't see any specific factors in this accident that directly relate to single pilot versus dual pilot. For example, workload, as Dr. Sevillian mentioned. It doesn't take much workload to turn the helicopter around and land it at Van Nuys. It takes a good decision and a good support to do that. Now, having said that, the FAA does actually aid passengers in looking for the truly unsafe, those rogue operators. The FAA's Safe Air Charter program is available, and people can look for those who are really operating the fly-by-night type of operation. But I want to make it clear that that is not the type of operator that we believe Island Express is.
Thank you. We did find some deficiencies in their operations, in the Island Express operations. What can you enumerate some of those?
Yes, sir. In fact, we've already discussed some of the things here in that they were not incorporating the SMS. We don't feel that's not a rogue type of thing. They just didn't know any better. That's what we have here. Is the deficiencies that they had was through ignorance in the true sense of the word. They just didn't know how to incorporate those components of SMS and safety program.
Great, thank you very much. Certainly, I've got more questions, and we'll catch those in the next round. Vice Chairman Landsberg.
I want to follow up a bit more on the SMS situation. We've had a recommendation for voluntary SMS as well as mandatory for some time. Mr. English, could you discuss the concept of scalability? Because I think some of the challenges that some of the operators have is that it has to be this huge, very complicated type of system. So talk about scalability, if you would, sir.
Yes, I can. And you're exactly right. SMS is not necessarily an enormous type of program. It can be scaled to even the smallest mom and pop operation using the appropriate components. Dr. Sevillian, I know, is prepared to get deeply into that for you.
Yes. In terms of the SMS, the FAA has provided information to operators, whether you have a small organization, medium, or large. In this case, Island Express could be considered a small organization. However, the 4 components of SMS still apply, as we discussed earlier, which means that they should be understanding that they need to implement those components of SMS within Island Express.
So it would be different, say, for the small operator, Island Express, say, versus petroleum helicopters, which is a much larger type of operation. The concept is the same, but the actual implementation would be appropriate for their level of operation. Am I understanding that correctly?
That is correct. And the guidance that the FAA has provided helps organizations integrate their safety management processes with the unique business models.
The other area I want to talk about, and we've had some recommendations out about flight data monitoring, which in today's technology is not tremendously complicated. As humans, we behave differently when we're being watched. A former president once said, trust but verify. And you only need to put a policeman on the side of the road or have a speed camera that people know about, and you see behavior is changed considerably. I think with the flight data monitoring, if organizations are using it, it changes the behavior. I mean, this is how the airlines work. Do you have any thoughts on that concept and how it affects people if an organization does, in fact, periodically audit whether crews are actually doing what they say they're going to be doing according to their operation specifications?
Yes, sir. In fact, we have reiterated a flight data monitoring recommendation along with this report, or proposed reiteration. And that's exactly right. Flight data monitoring is more than just a gadget. It's the program associated with that, and using that aggregate data to feed back in and make sure that, as you say, people are operating within their specified parameters.
Yeah, I find in terms of the training environment or the checking environment, everybody is on their best behavior. And I think we saw that here, that the FAA's principal operations inspector said that the crash pilot here was, doing an exemplary job because he was behaving differently. And as we get into our findings, I think we find out that in the real world, when he knows that he's pretty much on his own and there isn't an inspector sitting next to him, it's a different environment. Mr. Chairman, I don't think I have any further questions at this point. I want to thank everybody for their efforts and look forward to our further deliberations.
Vice Chairman, thank you very much. Member Hamady.
Thank you very much. I'd like to ask about cockpit voice recorders and flight data recorders. We have some recommendations on those. Whoever, Mr. English or someone else can pop up for those. Was there a CVR on the helicopter when it was manufactured?
Yes, ma'am. It was delivered with a CVR.
And when Island Express purchased the helicopter in 2015, they made some modifications to the helicopter, which also involved removing the CVR.
That's correct.
And under current regulations, what operations right now in aviation require cockpit voice recorders and flight data recorders?
This particular flight, the VFR, the single pilot operation, did not require a CVR. The regulations are quite complicated, so I will defer to Mr. Babcock from our recorders lab, who can explain that to you.
Thank you.
Good morning. For cockpit voice recorders, the general rule is 2 engines and 2 pilots and 6 passenger seats or more. For flight data recorders, it gets vastly more complicated, taking into account the data manufacturer, the helicopter, and the number of passenger seats. For this particular helicopter, it was manufactured before any flight data recorder requirements would have applied for the number of seats it had.
What's the safety advantage? Because we get people on the outside say you only want CVRs or FDRs to conduct investigations, to help you in your investigations. What's the response to that? How does it improve? How do they improve safety?
Well, ma'am, we like to believe that our investigations do improve safety, first of all. And CVRs and FDRs are primarily intended for investigative purposes. However, similar devices, and such as Vice Chairman Landsberg was mentioning, can also be used within a flight data monitoring program, non-punitive type programs, to detect various precursors to accidents.
In the report, we mentioned a particular helicopter crash where there were benefits to having a CVR and an FDR on the helicopter. Can you talk about that?
Yes, ma'am. Obviously, we like to have properly recorded operating recorders to benefit our investigative ability. In this particular case, having recorders of some type or another might have helped us clarify some of the items that we've had to infer from other data. For example, if there were any alerts going off in the cockpit, if the pilot was actually saying anything to the passengers, if there was video, we might be able to see more details about the weather or where exactly his eyes were looking. Flight data recording or some other type of electronic recording might be able to clarify exactly how he was working the autopilot, for example.
Well, in this one in particular, because of what we were able to gather from those devices, we actually issued 3 urgent safety recommendations on airworthiness issues. If it weren't for the recorders, we wouldn't have had the information, and that's where it is key for improving safety. In fact, we've seen other areas and other modes where cameras or recorders are critical for safety purposes, not just for our investigations. I'll take a recent rail example where we looked at a train crash in DuPont, Washington, and if it wasn't for the camera recording inside the cab, we wouldn't have known that the locomotive engineer wasn't trained properly and really looked into the training deficiencies of Amtrak. Why is it important to have crash resistant recorders, and are they also fire resistant?
The crash resistant recorders are and fire resistance to some effect are important in the case of the accident, of course. Surviving, especially something like this, would be important for us. For flight data monitoring, it's not necessary.
Okay, and I'm actually going to come back to this on a couple of other things, but my time is run out. I will, with my 23 seconds, mention one thing on SMS just to close that out, which was the last communication we received from FAA on SMS for Part 135 indicated they were having difficulty because of 2 executive orders on 2-for-1. You have to eliminate 2 regulations for each new regulation you implement, and those have been rescinded by the Biden administration. So I'll look forward to FAA's renewed efforts on SMS for Part 135. Thank you.
Member Hominy, thank you very much. And Member Graham.
Thank you, Mr. Chairman. I'd like to stay with the flight data monitoring devices and programs. To put it simply, flight data, for those that are listening and not sure what flight data monitoring devices do, they help identify and correct deviations before an accident occurs. So it allows the operation to look and see if there's been deviations from maybe an aircraft limitation or an operational limitation that has been put in their operating manual, and allows them to see that and then go correct it in a non-punitive way, is the way the program monitoring programs are done. And if you eliminate those near misses or those minor hazards out there, then hopefully you eliminate the risk of the major accident that could result by not looking at these trends and mitigating the risk. In 2014, when the FAA required flight data monitoring devices for air ambulance operators, they stopped short of requiring a flight data monitoring program. So my question is, what is the benefit of a flight data or a flight monitoring device without implementing a flight data monitoring program?
We think the two are required to go hand in hand.
Absolutely. What was the FAA's reasoning for not requiring a FDM program in this case?
I think Mr. Hoyt can speak to the recommendation response.
The FAA basically told us that it has guidance available for operators to implement flight data monitoring programs if they choose to do so, but it decided not to actually require the program.
Yeah, and I think part of that is they thought, did they think that they were going to have to get involved with their flight data monitoring program like a FOQA program, a flight operational quality assurance program that like the airlines have?
Correct, yeah. And they basically said that in order to protect for the information to stay protected, it needs to be voluntarily submitted and participation in a voluntary program such as FOQA.
Absolutely. So I think they just kind of want to not have to figure out the resources, as in human resources, to be part of that program, which is unfortunate. So I did notice that the FAA administrator in October, speaking to a group, actually talked about flight data monitoring, and I quote here from him: "Part and parcel of SMS are the practices of flight data monitoring and safety reporting. These are proactive, data-driven approaches to oversight that prioritize safety above all else." So I really appreciate the administrator's support of flight data monitoring, and I really look forward to working with him and the FAA to prevent and save lives by working with flight data monitoring programs. And with that, that's all the questions I have, Mr. Chairman. Thank you.
Thank you, Member Graham. Mr. English, I want to come back to something that was said before the break. I'm sorry, in my last line of questioning. You had indicated that, I think you said that Island Express was a safe operation. Is that, am I paraphrasing that correctly?
I would say there wouldn't be any indication that Island Express was uniquely unsafe or a problem operator.
Which company had this crash, Mr. English?
Well, Island Express, of course.
So I'm seeing a disconnect here. What are your thoughts on that? I mean, this company had a crash and you're saying there's nothing to indicate that they were not safe.
Well, you asked, I think the concept of that questioning was how a consumer could, detect an unsafe operator, and there was nothing inherent about this operator that would indicate they were unsafe. I mean, I think we see crashes with other carriers and don't particularly indicate that they are unsafe, but they've had a gap, they've had a flaw, perhaps they didn't know any better, but that doesn't necessarily make them a problem operator. They just need to do some things differently or know something differently.
Thank you. In fact, by most measures, the interviews that we conducted, the pilot was well thought of, well regarded. He was the chief pilot, had good credentials, and I think this illustrates that even good pilots can end up in bad situations. And I know that I flew for 32 years, and there's certainly several occasions along the way that I made bad decisions and exercise poor judgment. And I think that's a lesson right there, is that we all are subjected to the term I was told years ago was sludge, SLOJ, sudden loss of judgment. And here's a case where a pilot who is well regarded apparently got into a very bad situation. So let me see if I understand this. So is basically the scenario that we believe happened is that he's flying along, he realizes that he's sort of getting boxed in with visibility, and then he must have made the decision, you know what, I'm just going to punch up through these clouds and get on top. Is that basically the scenario that we believe happened?
I think that's correct, and I heartily agree with your statement that this is good people can make a bad decision, and we really want to get to the bottom of why.
Yeah, thank you very much. So therefore, we need redundancy in the system so that when somebody does make a bad mistake or commit an error, there's enough redundancy in the system to be able to trap those errors before they become consequential. And so one of the things I want to know is that what can the helicopter industry do to help pilots who end up in inadvertent IMC? I flew an Airbus Airbus airplane for many years. It had flight envelope protections. It would not let me take the airplane outside of a safe envelope. Has there been any consideration to something like that for helicopters? I think back to general aviation, I believe there's one or perhaps more avionics manufacturers that somebody can press a button and it will right the airplane. So are there any thoughts about that for the helicopter industry that you're aware of?
Sir, that technology does exist for helicopters. There is a major avionics manufacturer that makes an autopilot with electronic stability protection and the level button that you described. Not sure if it would apply to this. This is kind of a legacy aircraft, but that technology does exist. It's coming down in price. The technology is advancing, so it does exist out there in the industry now, and it's getting into lower and lower costs.
Thank you very much. I always read the party submissions, and Island Express offered a party submission whereby they made a number of statements about how the controllers did or did not perform properly. Frankly, in reading through the case, I didn't see any issues. In fact, I saw some things that were wrong in the Island Express submission. But basically, they talk about the controller's multiple errors, the alleged failure to properly communicate termination of radar flight following, the incomplete position relief briefing between the two pilots, the lack of knowledge of the current weather conditions, which monopolized the accident pilot's attention during a critical phase of flight, and by causing him to make multiple radio calls. So here's my question. Did any of the air traffic control actions, errors, or omissions contribute in any way to this horrible tragedy?
No, sir.
Thank you very much. Vice Chairman Landsberg, questions for you, sir. Thank you, Mr. English.
No further questions, Mr. Chairman. Thank you.
Thank you. Member Hamady.
Yes, thank you. I wanted to get back to flight data monitoring for a second, and I just wanted to highlight something that the U.S. Helicopter Safety Team Working Group said, which was data recording devices enable proactive intervention before an event occurs based on some of the fatal accidents in a data set they looked at. The U.S. Helicopter Safety Team Working Group thought flight data monitoring systems could have made a difference. Hazardous behavior could have been identified with the opportunity to break the accident chain before it resulted in a fatality. Now, we have recommended flight data monitoring for 12 years. We've recommended SMS for 12 years in one form or another, starting with HEMS. And we've recommended recorders going back 22 years. On flight data monitoring, the FAA responded at one point to our recommendations a pretty, I thought, somewhat aggressively in 2017, stating the FAA will not initiate rulemaking that mandates operators to establish flight data monitoring programs. And at the time, they said it was because the cost-benefit analysis did not show any benefits. In fact, does anyone want to guess what they showed as the costs to the industry over 10 years and what the benefits were? My guess is Mr. Hoyt knows the answer to that question. I can't hear you.
Sorry, the cost that the FAA estimated for FDMs was at 20.6 million, and the benefit was $0.
Zero benefits, they said. Now, I want to look at that for a second, because at the time we had showed them our data from 2000 to 2015, where we investigated 7 accidents where a flight data monitoring program could have prevented. Those 7 accidents killed 53 people and injured another 4. So if I add to that, after 2015, Togiak, Alaska, where 3 were killed, 2 killed in Teterboro, 3 in Zaleski, and 9 here in this crash, all of which we advocated for flight data monitoring. The DOT, Mr. Hoyt, do you know how much the price tag DOT puts for a life?
Yes, I believe it's at 9.6 million per fatality.
9.6 million for a fatality. For an injury, for serious injuries, it's 987,000. So if you look at 67 people killed, which we identified, and 4 injured, you come up with 676 million, and with a cost over 20 years then of roughly $42 million. So seems to me that the benefit from lives saved alone, using what I think is a very flawed, broken cost-benefit analysis that I hope the current administration revisits, seems to greatly exceed what FAA estimated the costs to be. And so with that, you know, we continue, and this board meeting is just the first of what I believe is a long series of the NTSB advocating for our recommendations to be implemented. And I will have one more question on how we do that, but I'm coming up on some running out of time, so I will go ahead and yield back my 46 seconds.
Thank you very much. I don't believe any of my colleagues have any additional questions in addition to myself. Do any of my colleagues have any questions before we go back to Member Hamady? Okay, seeing none, Member Hamady, you are recognized.
Yeah, I just wanted to emphasize one more time that for the NTSB, this is just really, at least for the board members, really the first step in our process of improving safety. After a board meeting, safety isn't improved until we get our recommendations implemented. And so we work hard after this board meeting to do that. And we have a great team at the NTSB to accomplish that. And what I want to do is recognize Ms. Hatchett, who runs our safety recommendation and communications Office of Safety Recommendations and Communications, to talk about what we do after the board meeting to get our recommendations implemented.
Thank you, Member Hamady, and I appreciate the opportunity to address this. I think it's really important that we unpack that for those that are viewing the board meeting today. The agency investigates accidents, including the Sikorsky crash, to determine what went wrong and issue safety recommendations to prevent future accidents and save lives. But as you know, the recommendations don't do any good unless they're acted on. So after the board meeting ends, our work continues. In my office, the Office of Safety Recommendations and Communications, we track and evaluate responses to the board's recommendations, and we work with all of you to advocate for their adoption. For those viewing the board meeting, I want to unpack that. So let me explain how all this works. Our safety recommendations team records and tracks all responses to recommendations that we issue. The organization that receives the recommendations, such as the FAA, writes to the NTSB to describe what they plan to do and what actions they plan to take in order to address the recommendations. The team evaluates the response and determines whether the action taken will satisfy the recommendation or is likely to once the action is completed. A letter is prepared and it's approved by the board describing our evaluation of the response, and a classification of the recommendation is made. The team also contacts recipients because we want to make sure that we're doing our due diligence for those who have not responded to a recommendation for some time to ensure that progress is being made in that regard. Our government affairs teams, they are actively engaged with Congress, governors, state legislatures about our investigations and recommendations, and monitors federal and state legislative efforts to improve safety. We will provide requested information to congressional staff about our open recommendations, including those discussed in today's meeting, such as recorders. As you know, we regularly update Congress regarding the status of recommendations as they conduct oversight and consider legislation. We facilitate board member and NTSB staff appearances to keep open safety recommendations in the forefront of public discussion. And I know that we have worked with the Air Charter Foundation and advocated on behalf of SMS. I believe last year the chairman spoke at the training center in that regard. And also we had a roundtable, I think it was a day after the Sikorsky helicopter incident, the crash with the helicopter foundation. I'm sorry, the Helicopter Air Charter Safety Foundation. So we are actively engaged there. So we continue to work with the board and look for those opportunities to keep the pressure on those who receive our recommendation. Our advocacy team, and I know that member Chapman mentioned this, he mentioned the most wanted list. So the most wanted list is the premier advocacy tool by which we identify the top safety improvements that can be made to prevent accidents, minimize injuries, and save lives in the future. The issues that are under discussion today, specifically recorders, flight data monitoring, safety management systems, and as well as you know, they're not new. They're not new to the agency. They are such important topics. I believe the chairman mentioned this in his opening remarks, and others have mentioned it as well, that it is on our current most wanted list under Improve the Safety of Part 135 Aircraft Flight Operations. So we have a whole effort, a comprehensive approach that, you know, when the gavel goes down and the board meeting concludes, it truly at that point is the beginning, not the end of a critical aspect of our work. So I appreciate you providing the time so those that are viewing this understand how important what we do is, and that we really continue our efforts long after the board meeting concludes.
Oh, I was on mute. I was telling you thank you. That's how it goes in the virtual environment. Thank you very much, Mr. Chairman.
Well, you're quite welcome. Thank you very much. Are there any other questions from my colleagues on the board? Okay, seeing none, Mr. Curtis, if you'd please read the proposed findings.
Certainly, Chairman. As a result of this investigation, staff proposes 13 findings. Number 1, none of the following safety issues were identified for the accident flight. 1, pilot qualification deficiencies or impairment due to medical condition, alcohol, other drugs, or fatigue. 2, helicopter malfunction or failure, or 3, pressure on the pilot from Island Express Helicopters, Inc., the air charter broker, or the client to complete the flight. Number 2, although the air traffic controller's failure to report the loss of radar contact and radar communication with the accident flight was inconsistent with air traffic control procedures, this deficiency did not contribute to the accident or affect its survivability. Number 3, had the pilot completed an updated flight risk analysis form for the accident flight that considered the weather information available at the time the flight departed, the flight would have remained within the company's low risk category, but would have required the pilot to seek input from the director of operations and to provide an alternative plan. Number 4, at the time the pilot took action to initiate a climb, the helicopter had already begun penetrating clouds, and the pilot lost visual reference to the horizon and the ground. The loss of outside visual reference was possibly intermittent at first, but likely complete by the time the flight began to enter the left turn that diverged from its route over US Route 101. Number 5, the pilot's poor decision to fly at an excessive airspeed for the weather conditions was inconsistent with his adverse weather avoidance training and reduced the time available for him to choose an alternative course of action to avoid entering instrument meteorological conditions. Number 6, the pilot experienced spatial disorientation while climbing the helicopter in instrument meteorological conditions, which led to his loss of helicopter control and the resulting collision with terrain. Number 7, the pilot's decision to continue the flight into deteriorating weather conditions was likely influenced by his self-induced pressure to fulfill the client's travel needs, his lack of an alternative plan, and his planned continuation bias, which strengthened as the flight neared the destination. Number 8, Island Express Helicopters, Inc.'s lack of a documented policy and safety assurance evaluations to ensure that its pilots were consistently and correctly completing the flight risk analysis forms hindered the effectiveness of the form as a risk management tool. Number 9, a fully implemented mandatory safety management system could enhance Island Express Helicopter, Inc.'s ability to manage risks. Number 10, the use of appropriate simulation devices in scenario-based helicopter pilot training has the potential to improve pilots' abilities to accurately assess weather and make appropriate weather-related decisions. Number 11, objective research to evaluate spatial disorientation simulation technologies may help determine which applications are most effective for training pilots to recognize the onset of spatial disorientation and successfully mitigate it. Number 12, a pilot data monitoring program which can enable an operator to identify and mitigate factors that may influence deviations from established norms and procedures can be particularly beneficial for operators like Island Express Helicopters, Inc., that conduct single pilot operations and have little opportunity to directly observe their pilots in the operational environment. And number 13, a crash-resistant flight recorder system that records parametric data and cockpit audio and images with a view of the cockpit environment to include as much of the outside view as possible could have provided valuable information about the visual cues associated with the adverse weather and the pilot's focus of attention in the cockpit following the flight's entry into instrument meteorological conditions.
Mr. Curtis, thank you very much for reading those proposed findings. At this time, we'll do a roll call of the board to ensure that we are prepared to deliberate. Vice Chairman Landsberg.
I'm ready to deliberate, sir.
Thank you, sir. Member Hamady.
I'm ready to deliberate as well.
Thank you. Member Graham.
Member Graham's ready to deliberate.
Great, thank you. Let me pin you up here. And Member Chapman.
I'm present, Mr. Chairman, and ready for deliberations.
Thank you very much. I believe we have a proposed amendment. Member Chapman, are you planning to offer a proposed amendment?
Yes, Mr. Chairman, I have a proposed amendment to.
Okay. All right, that's good. Let me just see. Does anybody else have any others? Okay, great. Member Chapman, you are recognized, sir. Thank you very much.
Yes, sir. I have a proposed amendment to finding number 7, and this is in conjunction with further discussion that we will likely have as we proceed to discussion of the probable cause, the draft probable cause. This has to do with my concern about
Member Chapman, if you'd please make your motion and see if we get a second, then you can discuss it.
Certainly. I move that we amend finding number 7 as follows. The pilot's decision to continue the flight into deteriorating weather conditions was strike likely, influenced by his insert possible self-induced pressure to fulfill the client's travel needs, his lack of an alternative plan, and his planned continuation bias, which strengthened as the flight neared the destination. And I circulated this language. It's the same language that you all saw yesterday afternoon.
Thank you very much. You've heard Member Chapman's motion. Is there a second?
Second for discussion.
Okay, Member Hamady has seconded it for discussion, and Member Chapman, you are recognized for discussion.
Yes, sir. As I indicated, this relates to my concern about identifying self-induced pressure, definitively at least, as a contributing factor in the probable cause. As I've said earlier during the question and answer, it certainly could be that self-induced pressure played a role, and it's reasonable to discuss it as a possibility, but there's little objective evidence on which to base the finding that it actually contributed to the pilot's decision-making, other than the fact that there was a relationship between the pilot and the client. And I know we all agree that we should avoid determining contributing factors based on speculation. That's my concern, is that we need to avoid, in crafting this, we need to avoid being too speculative about the extent to which self-induced pressure played a role, and that self-induced pressure resulted from the relationship with the client.
Okay, so thank you. As it relates to the finding, you're proposing to change, strike the word likely and add the word possible. So any discussion? Please, I open it up. Vice Chairman Landsberg.
Yeah, I'm conflicted on this because I certainly understand Member Chapman's concern about us not going into speculative areas. But I think when we get into the human factors aspect, as Dr. Sevillian has discussed and Mr. English, I see, to use the legal term, the preponderance of the evidence, if you will, and we're pretty clear that there was no alternative plan. The pilot had multiple opportunities to change. We saw him deliberately descending as he was getting pinched, as I think is the technical term, between the ground and the clouds. We also know that, at least I know from personal experience, and maybe some of my fellow pilots will agree, that the closer you get to the destination, the more you think that maybe, just maybe, you can pull this off. The other point is he didn't follow any of the recommended mitigations for entering instrument meteorological conditions, or to properly, once he had entered them, configure the aircraft by slowing down, by starting a climb, by activating the autopilot. None of that happened. And this is unfortunately not the first time we've seen this kind of behavior. I will cite several crashes that go before. Buddy Holly and Patsy Cline, to go back a very long way, and then just to show you that I'm not totally clueless on culture, more recently the Aaliyah crash in the Bahamas, and Stevie Ray Vaughan, which was another helicopter crash involving instrument meteorological conditions. And in all of those cases, you're dealing with someone of great star power status and pilots who desperately want to do a good job for the customer. So my sense is that the preponderance of the evidence, let's call it 51%, indicate that this pilot really wanted to get where he was going. So thank you for the opportunity to express my views.
Thank you, Member Hamidi.
Thank you. And just for clarification, Member Chapman, your amendment is really modifying self-induced pressure. It's maintaining as is the reference to lack of an alternative plan continuation bias, correct?
That's my intention, yes.
Yeah. So, on this issue, I was equally conflicted. I looked at FAA guidance on aeronautical decision-making and human psychology, and it very clearly states there are tendencies or operational pitfalls that come with the development of pilot experience. These are classic behavioral traps into which pilots have been known to fall. More experienced pilots, as a rule, try to complete a flight as planned, please passengers, and meet schedules. And so, but with that, where I was a little bit concerned is I didn't see evidence of any of that in the docket. And I understand I am not a pilot, but there were actually comments more about him being willing to cancel flights for weather, and also in response to pressure from OC helicopters. In fact, I think the statement was from one individual, he had no problem canceling flights. He had told OC helicopters on several occasions that, and OC helicopters would get upset if he canceled a flight, and he responded by sending them a screenshot of the weather and would not be pressured into flying. So, I mean, I know that's a different issue, but there was more evidence to the contrary of self-induced pressure in the docket itself.
Okay, thank you. Member Graham, do you have any comments?
At this time, no. I think I have more or less a question for the investigative team on this when we get to that.
Yeah, thanks. And all we're talking about here is this finding. I think the discussions thus far have sort of been teed up for the probable cause. So let's focus on the finding here. We're talking about changing the word likely and later inserting the word possible. So I'll tell you where I stand. I could support Member Chapman's finding amendment. I do not plan to support at this time. Now I'll wait and hear the discussion, but I do not plan to support an amendment on the probable cause, but we haven't gotten there yet. So with that, staff, what would be your feeling if we were to adopt the amendment to finding number 7?
Mr. Chairman, I think I could take that first, or perhaps Ms. Schultz can chime in. But I think staff is quite convinced that likely is the most appropriate word here. I think it's important to note that the use of self-induced pressure here is not an individual flaw identified in this pilot. This is something that the analysis is identified as a trait of any pilot, of any human being, and it's important to note that is solidly supported by the preponderance of evidence, as the Vice Chairman mentioned, in the literature. So we do believe that as solid a conclusion as the spatial disorientation, whereas possible just leaves it open to being very weak in our conclusion, and we are quite convinced that self-induced pressure is actually the factor here. I think Director Schultz may have something to add, or Dr. Sevillian.
Thank you, Mr. English. I don't have anything further to add, but I would say that the staff believes that the evidence that we have collected in this investigation does frame the likely scenario. So I would concur with what Mr. English said, and Dr. Sevillian, if you would like to add any details to that, please do so.
There's nothing to add here, but I do agree that it should read as likely based on the objective evidence that we collected throughout numerous interviews with Island Express helicopters.
Okay, thank you. Member Chapman, would you like to perhaps have the final word on this? Not necessarily the final word, but what are your thoughts?
I do have a question in terms of how this finding is structured. I'm somewhat confused by the discussion just now in terms of the word likely. Is likely intended to modify only self-induced pressure, or does it modify all that follows? Likely self-induced pressure, likely lack of an alternative plan, likely plan continuation basis, because I think it's clear he didn't have an alternative plan. I would argue it's clear that there was plan continuation bias. The only concern I have is the extent to which we can establish that there was self-induced pressure. So if likely is intended to modify all three of those factors, we probably have a little bit of a concern here in terms of how this finding is structured. That was my reason for striking likely. I think likely unnecessarily modifies all three factors, and I don't think that there's a real question with respect to plan continuation bias and lack of an alternative plan.
Ms. Schultz, I think I'm seeing your name blinking there. Would you like to jump in on that?
Sure. My belief is that likely is qualifying the self-induced pressure and not the other items in that sentence. But I would ask Mr. English or our writer Kathy Gagne to correct my English if that's not the case.
Yeah, let's hear from Kathy Gagne, because she's our report writer. The way I read it is that because of the commas in there, it is modifying all three of those issues. Kathy, Ms. Gagne.
Yes, good afternoon. Well, it's interesting that the discussion on either or and possibly omitting it does bring up the benefit of having it there at all. I'm going to have to go back and look at the context of the analysis leading up to the finding, because I know we certainly self-induced pressure is stronger than possibly, and how staff wants that worded. But I do need to look at where the likely how that originated based on the flow of the analysis.
Well, okay, we can argue about the English of it, but yeah, would you like to take a break to discuss that?
Yes, Chairman, I think this might be a straightforward solution, so I would suggest that we take a very short break to discuss that as staff.
Okay, we will take your advice on that. We will be in recess till 12:35. That'll give you 12 minutes, and we'll reconvene at 12:35. We are in recess. Cameras and mics, I would encourage you to consider turning those off. Thank you. We're back in session. Ms. Schultz, have you and the staff reached a determination on the structure of this sentence?
Thank you, Chairman. Yes, we have. We would like it to stay the way it is, and let me explain. If you read the construct of the sentence, it starts with the pilot's decision. So these three variables that we highlight, the self-induced pressure, the lack of an alternative plan, and the plan continuation bias, we're looking at those from the perspective of what's going on inside the pilot's head. And based on the evidence we have, we can say likely, but we cannot dissect that by individual factor area, because we don't ultimately know. That's why we're using the qualifier likely, what was going on inside his head. But based on the evidence that we see and the human factor science, that's likely, we believe, is the term. I think the Vice Chairman used the terminology preponderance of evidence. I would also add that this approach is consistent with the way the Office of Aviation Safety has identified these type of findings when it relates to human factors variables. So we can certainly open up if you would like to ask Mr. or Dr. Sevillian additional questions, but that would be our position.
Thank you very much. Member Chapman, you have a motion on the table. Any thoughts at this point?
Mr. Chairman, I'm interested in whether the staff would be more comfortable with my amendment if the term likely were substituted for the word possible. In other words, it would describe the self-induced pressure as likely self-induced pressure rather than possible self-induced pressure.
So, Member Chapman, I think our concern with that might just be that likely we do intend that to qualify all three factors there, because as I mentioned, we can't say that that was any less of a factor than the lack of the alternative plan in place or his plan continuation bias. So we would like likely to qualify all three.
Mr. Chairman, I'm comfortable with my amendment as originally proposed and suggest that we go forward.
Okay, thank you very much. Is there any other discussion before I call for the question? Okay, it's been, Member Hamady. I'm sorry, it looked like you were going to say something there. Okay, thanks. It's been moved and seconded by Member Chapman to state the motion would be the pilot's decision to continue the flight into deteriorating weather conditions was, strike the word likely, influenced by his, insert the word possible, self-induced pressure to fulfill the client's travel needs, his lack of an alternative plan, and his planned continuation bias, which strengthened as the flight neared the destination. It's been moved and seconded. We'll do a roll call vote, and there's no further discussion. We'll do a roll call vote. Vice Chairman Landsberg.
Vice Chairman very respectfully votes nay.
Vice Chairman votes nay. Member Hamady.
Yeah, I think with the additional information that likely is meant to modify all of those, respectfully, my vote is nay.
Member Hamady votes nay. Member Graham.
Thank you, Mr. Chairman. I respectfully am going to vote nay also, but I struggled with this too for weeks and we have been on the fence, but that additional information made the difference for me.
Thank you. Member Graham votes nay, respectfully. Member Chapman.
And I vote aye, Mr. Chairman.
Member Chapman votes aye. The chairman respectfully, after also listening to the discussion, the chairman votes nay. So the motion fails. The vote is 4 nays, 1 aye. The motion fails. Do we have any further amendments to the findings? Seeing none, do I have a motion to adopt the findings as proposed?
So moved.
It's been moved by the vice chairman. Is there
Second.
a second? Member Graham seconds. Any discussion on the findings? Okay, it's been moved and seconded to adopt the findings as presented. We'll vote with the roll call again. Vice Chairman Landsberg.
Vice Chairman votes aye.
Vice Chairman votes aye. Member Homendy.
Aye.
Member Homendy votes aye. Member Graham.
Aye.
Member Graham votes aye. Member Chapman.
Aye.
Member Chapman votes aye. The chairman votes aye. The findings have been adopted unanimously. We'll move now to the probable cause. So, Mr. Curtis, if you'll please read the probable cause, the draft probable cause.
Staff proposes the following probable cause. The National Transportation Safety Board determines that the probable cause of this accident was the pilot's decision to continue flight under visual flight rules into instrument meteorological conditions, which resulted in the pilot's spatial disorientation and loss of control. Contributing to the accident was the pilot's self-induced pressure and planned continuation bias, which has adversely affected his decision-making, and Island Express Helicopters, Inc.'s inadequate review and oversight of its safety management processes. Back to you, Chairman.
Chairman, you're muted.
Yep, never done that before. Thank you, Mr. Curtis, for reading the proposed probable cause. Member Chapman, I'm aware that you may offer an amendment on the probable cause. Are there any other proposed amendments? Okay, with that, Member Chapman, you are recognized.
Mr. Chairman, I circulated 2 possible amendments. I want to refer everyone to what I labeled amendment number 2. And I am going to modify that just slightly. I'm going to, and I'll read the entire text, but I'm going to substitute the word likely for the word possible in my amendment as I originally circulated it. And if you'd like, I can read the amendment.
If you would, please. Thank you very much.
The National Transportation Safety Board determines that the probable cause of this accident was the pilot's decision to continue flight under visual flight rules into instrument meteorological conditions, which resulted in the pilot's spatial disorientation and loss of control. Contributing to the accident was the pilot's likely self-induced pressure and his, insert his, planned continuation bias, which adversely affected his decision-making, and Island Express Helicopter, Inc.'s inadequate review and oversight of its safety management processes.
Okay, it's been moved per Member Chapman's motion. Is there a second?
Second.
Member Homendy seconds. Discussion. Member Chapman, you're recognized.
For all the reasons I've discussed already, Mr. Chairman, I do have a concern about the definitive nature of our identification here of self-induced pressure as a contributing factor. I think it's certainly possible, even likely, that it was present and it contributed. So I certainly don't object to having it mentioned. I just think that we should be less definitive, and that's the purpose of my inserting the term likely. I've inserted the term his just to ensure that there's no confusion in terms of what I'm seeking to modify here. I'm seeking to modify only self-induced pressure, not the other factors identified as contributing factors.
Okay, thank you. Thank you very much. For my colleagues who would like to discuss this or ask questions about this. Vice Chairman, please.
I think I could support that based on our previous discussion. I think likely would be an appropriate modifier, and it leaves the rest of it unchanged.
Member Homendy, any questions? I saw you nodding your head. Any thoughts on that?
I agree. I could support that. The only thing I would ask staff is we typically do not indicate in a probable cause his or her. We usually indicate pilot. I just wanted to get the staff's views on that when we get to the point of staff's views, but I do support the amendment.
Okay, thank you very much. Member Graham, any thoughts for you?
I could support that, and I agree with Member Hamady. I'd like to hear their comments on that. Thank you.
Yeah, I tentatively, I'd say I could support it. I got burned on the last one because I jumped in there and said I could, and then I changed my mind. The thing is, though, I mean, and I respect what you're saying, Member Chapman. I mean, are we changing small dog to puppy? Is it a distinction without difference? What's the difference between possible and likely? Which has more weight? And at this point, I'm not willing to say that possible has more or less weight than likely. Likely is in fact a term that we use often, but often in these board meetings, we are deliberating literally that one word there. So what you want to do is, so what you're doing is modifying, and you're modifying the how much weight we are giving to those issues. Is that right?
Yes, that's correct, Mr. Chairman. And I really have I have offered this suggestion based upon some comments that were made by staff earlier, suggesting that it was more than possible, that it was really likely. I think there was a specific reference made to that, and I agree. I think that's fair. And so I intend to be offering a term here which carries more weight than possible.
Okay, all right. And I see too some confusion on my part. Yeah, the word possible was not even in there originally, so I got it. So you're modifying it, and you modified the original version that you had. Okay, I think I see what you're doing. All right, Vice Chairman, you look like you had a question or so.
I was confused by your confusion, sir. I think all he's doing is inserting the word likely ahead of self-induced pressure, and then we're trying to figure out how to deal with the rest of the sentence where we'd like some staff input.
And I would certainly defer to staff in terms of whether his should be his or the pilot's, or however that should be constructed is fine with me.
Great. So let's go to staff. Would love to hear staff's viewpoints on all of this, including the pronoun there. And so, staff, we defer to you.
I'll ask Mr. English to go ahead and respond.
Thank you, Ms. Schultz. In looking at first the amendment offered by Member Chapman, typically, in the construct of the report, the finding should support and be reflected in the PC statement. Staff can agree with the insertion of the word likely, as just proposed by Member Chapman. That does match with and is supported by the finding. As we just discussed regarding the finding, we do not prefer to bifurcate those particular issues so that additional insertion afterwards would then serve to bifurcate them, and likely would only apply to the self-induced pressure, whereas in the finding we have the word likely modifying all three factors. We're comfortable with that. So we would prefer that the insertion of the word likely, if it goes in, doesn't bifurcate from the others, which then I think eliminates your question about the pronoun. But if you do not accept that suggestion, I would have to defer to Ms. Gagne for the question of the pronoun. That would be an editorial.
So, Mr. English, just to be clear, what are you suggesting that contributing clause should state? How should it state?
If I remember Member Chapman's statement, it would say contributing to the accident was the pilot's likely self-induced pressure and planned continuation bias, et cetera, et cetera.
Mr. Chairman?
Yes, sir, please.
With due respect, I mean, I understand the point that's being made, but the probable cause and the finding don't reflect each other as currently written. There's no reference to lack of an alternative plan in the probable cause. That is referenced in the finding. And in the finding, likely apparently is meant to qualify all three, or at least the extent to which all three impacted the pilot's decision making. My intent here is to qualify only the extent to which there was or was not self-induced pressure. I don't intend to qualify planned continuation bias. I think that is pretty clearly established. So I think I understand the point that's being made, but I don't think it squares with the way that the finding is actually structured and how it mirrors or doesn't mirror, isn't mirrored in the probable cause, even without my amendment.
Okay. Discussion? Member Hamidi.
Mr. English, can you pop up again? The revised finding, the word likely is meant to modify all three, correct? It's meant to modify, let me go back to the finding. It's meant to modify self-induced pressure, it's meant to modify planned continuation bias, and meant to modify lack of an alternative plan. So I think that staff is just trying to keep it so likely is on self-induced pressure and on planned continuation bias. Is that correct?
Yes, ma'am. You said the revised finding. I think you mean the finding as proposed, since the revision did not pass. So the finding as proposed. I'm
sorry. Yes.
Right. Yeah. So the finding as proposed likely modifies all those phrases. If we go to the probable cause and we do not allow likely to modify all those phrases, we've increased the confidence on these without supporting finding or analysis. On planned continuation bias, for example, if we don't let likely modify planned continuation bias, we've kind of jumped a level, I think.
But Mr. English, likely was in the finding as originally proposed. It is not in the probable cause as originally proposed. So your argument doesn't square.
I think we think probable covers that, but the chairman is trying to weigh in on that, I believe.
Yeah, thank you. I think perhaps one way to deal with this would be, so they should be parallel. Whatever was in the finding should transfer over to the probable cause. And it's no longer a proposed finding. It is the finding that the board adopted. So we could make it parallel, so they're the same, by saying contributing to the accident was likely the pilot's self-induced pressure, his planned continuation bias, which adversely affect his decision making. But then that modifies Island Express helicopters' inadequate review and oversight of the safety management system. And I don't think we're in a position of wanting to modify that. What we're talking about here is modifying the self-induced pressure, the lack of an alternative plan, which, by the way, is not in the PC, and its planned continuation bias. So, but Member Graham, I think you were going to, you wanted to jump in there, I believe.
Well, yeah, I was just trying to clarify that too. So like you said, would we put contributing to the accident was likely, but we are using probable cause here, right? So do we really need to use likely? So, I mean, I may be overplaying my cards here. I don't know if the staff would like that in there, or would we just leave it the way it is? That's where I'm leaning at this point.
I mean, you're right, probable cause and likely. I mean, now we're saying it's probably likely. I mean, how many modifiers do we need?
Right.
So, Member Hamidi.
You're muted, Member Hamidi.
Man, I am having a problem with that mute button today, but I would just like to remind my colleagues that we've had many discussions about the word likely and probable causes, including on the New Hampshire crash where we inserted the word likely, and everyone supported that, even in the midst of the discussion of a probable cause. So I do support the amendment, but I just thought I'd point that out.
Well, it is true. We do debate literally that word likely many times. Member Chapman, did you run these possible amendments by staff?
They were shared yesterday, but with the term possible, not the term likely.
Yeah. And did you specifically share it with the staff and say, what are your thoughts on this?
I certainly invited comment. There were no comments.
Okay, thank you. So where are we? Is there?
How about a friendly amendment?
You have a friendly amendment? Please go ahead.
Well, with all this, and I understand what Member Chapman's talking about and what Member Hamidi brought up, which is so true. We've been back and forth with this. Since we had it in the finding, would you like that last sentence? I propose a friendly amendment of contributing to the accident was likely the pilot's self-induced pressure and planned continuation bias, which adversely affected his decision-making, comma, and Island Express Helicopter Incorporated's inadequate review and oversight of its safety management processes.
Yes, I had thought, I think I may have mentioned that earlier. However, does that then end up modifying to likely Island Express's inadequate review and oversight? Does that modify that down?
I'd have to ask the grammatical expert at that, that's for sure.
You could put a period after decision making and make that a separate sentence with the appropriate qualifier.
That is true. You could put a period there and say also contributing to the accident was Island Express Helicopter's inadequate review. We could do that, and then by doing that, by saying contributing to the accident was likely the pilot's self-induced pressure and planned continuation bias, which adversely affected his decision-making, period. Also contributing to the accident was Island Express Helicopter Inc.'s inadequate review and oversight of its safety management processes, I should say. So that would be for you, Member Chapman, to determine whether or not you'd like to proceed in that direction.
I'm open to that, Mr. Chairman. I'd be interested in the staff's input.
My name may be English, but I will defer to Ms. Gagne for the editorial English.
Hi, yeah. So based on the discussion we had about finding 7, about how strongly staff believes in these factors, I think moving likely as far as the new friendly amendment contributing to the accident was likely the pilots, I think is introducing a level of uncertainty that staff did not intend, that's modifying the decision making. I think staff has made the case on how they think these factors influence the decision making. So grammatically, I don't think I would support moving the likely on the friendly amendment. I think we should go back to discussing the original proposal and whether or not that will work.
Kathy, your recommendation was going back to the original motion that Member Chapman had offered.
Correct. Where he had offered contributing to the accident was the pilot's likely self-induced pressure and his planned continuation and bias. I think the other friendly amendment strayed us even further from the meaning we were intending. So I think maybe let's go back to Chapman's proposal.
Okay. I mean, all right. Well, Member Chapman, it's back to you, sir.
I'm out of ideas, Mr. Chairman. I'm not sure where everyone is on this. I'd be happy to take a vote on it if there's no further input.
Okay. Well, we can do that. I plan to call for the question unless there's any additional questions or comments.
can I just have a point of clarification? Are we voting on the friendly amendment changes, or are we voting on the original proposed?
Yeah, and I appreciate the clarification on that. As far as I'm concerned, we never agreed to the friendly amendment, so we would be back to the original, to Tom Chapman's original motion of adding the word likely and then the preposition, or excuse me, the pronoun his.
And I would suggest, Mr. Chairman, just to modify this slightly, we substitute the pilots for the term his. And I can read that. I can read that in its entirety if that would be helpful.
Yes, we're about to vote. It's been moved and seconded. Member Chapman will read the motion. I'm sorry, read the amendment. Please proceed.
My amendment that I'm proposing would have the probable cause read as follows. The National Transportation Safety Board determines that the probable cause of this accident was the pilot's decision to continue flight under visual flight rules into instrument meteorological conditions, which resulted in the pilot's spatial disorientation and loss of control. Contributing to the accident was the pilot's likely self-induced pressure and the pilot's planned continuation bias, which adversely affected his decision-making, and Island Express Helicopter's inadequate review and oversight of its safety management processes.
Okay, it's been moved and seconded. I do want to go back to this one point. In finding 7, we had the word likely. Likely was modifying self-induced pressure, and it was modifying planned continuation bias. In this particular case, it has not modified planned continuation bias.
Mr. Chairman, I would just point out it also modifies lack of an alternative plan, and there's no reference to alternative plan in the probable cause. I don't think they reflect each other even without my amendment.
Okay.
Go ahead, please.
I hate to ask this, but could we give staff a 5-minute break to look at the proposed modification of likely the pilot's self-induced pressure and plan continuation bias? Because I don't see the word likely as actually modifying decision-making, but.
Yeah, absolutely. I think that's a great idea, and we will do that. We're going to give staff until 1:15, which would be 12 minutes from now. So we're going to take a break, and we are cameras and microphones off. We are in recess. Okay, we are back in session. And would surely love to hear what staff's got to say.
Chairman, thank you. So staff has discussed Member Chapman's last flight change from his original, and we think that maybe this is the best approach. And Member Chapman, I'll read this, and for you, the chairman, and the rest of the board, see if this will, I think this will agree with where you were headed. Contributing to the accident was the pilot's likely self-induced pressure and the pilot's continuation bias, which adversely affected his decision-making, and Island Express helicopters' inadequate review and oversight of the safety management process. And I'll add to that while it would be staff's preference not to qualify the self-induced pressure over the continuation bias, we fully respect the board's position on this. So we think this is the best solution for the direction that we're heading. And I would also say that it's not the case that the findings are supporting our analysis and proposal for the probable cause. They're not always the exact translation. So I think this is consistent with the finding that the board just adopted, but it may also hopefully meet your needs, Member Chapman. So that's what staff would offer.
Okay, you may have possibly left out the word plan when you read it, but I know that you for planned continuation bias. But
yes.
So basically, it's back to Member Chapman's original amendment that he verbally read. Is that correct?
Yes, I believe that's the case, but we might ask Member Chapman to read it again because his original amendment used the word possible, but I think his verbal amendment was to insert likely instead of possible.
That's correct. Go ahead, Member Chapman,
That's
please.
correct, Mr. Chairman. And I think what I heard was the amendment as I read it verbally, but I'm happy to read it again.
Yes, and would it strike his and replace with insert the pilots? Is that correct?
I had suggested that, but I'm agnostic on that and would defer to staff.
Staff would support that.
All right. I'd like for Member Chapman to please restate his motion, and then we'll see. So if we need to discuss it further, but Member Chapman, please state your motion.
Here's my proposed amendment, Mr. Chairman. The National Transportation Safety Board determines that the probable cause of this accident was the pilot's decision to continue flight under visual flight rules into instrument meteorological conditions, which resulted in the pilot's spatial disorientation and loss of control. Contributing to the accident was the pilot's likely self-induced pressure and the pilot's planned continuation bias, which adversely affected his decision-making, and Island Express helicopters' inadequate review and oversight of its safety management processes.
All righty, and I think you read over Island Express Helicopter Inc.'s inadequate review, but that's what you want, I think.
Yes, correct.
All right, it's been moved. I believe Member Hamidi seconded it. Is there any further discussion on this one? Okay, seeing none, we're now going to take a roll call vote. Vice Chairman Landsberg, you've heard the motion. What is your vote, sir?
I have, Mr. Chairman, and I vote aye to support the amendment.
Thank you very much. Vice Chairman votes aye. Member Hamidi.
Aye.
Member Hamidi votes aye. Member Graham.
I vote aye.
Member Graham votes aye. Member Chapman.
Aye.
Member Chapman votes aye. The chairman votes aye. The motion has been passed unanimously. The probable cause has been adopted. Mr. Curtis, if you'll please read the proposed recommendations.
Certainly, Chairman. As a result of this investigation, staff proposes the following 4 new safety recommendations. 2 to the Federal Aviation Administration. Number 1, require the use of appropriate simulation devices during initial and recurrent pilot training for Title 14 Code of Federal Regulations, Part 135, Helicopter Operations, to provide scenario-based training that addresses the decision-making, skills, and procedures needed to recognize and respond to changing weather conditions in flight. Identify and apply mitigation strategies for avoiding adverse weather. Practice the transition to the use of flight instruments to reduce the risk of spatial disorientation, and maintain awareness of a variety of influences that can adversely affect pilot decision-making. Number 2, convene a multidisciplinary panel of aircraft performance, human factors, and aircraft operations specialists to evaluate spatial disorientation simulation technologies to determine which applications are most effective for training pilots to recognize the onset of spatial disorientation and successfully mitigate it, and make public a report on the committee's findings. And 2, to Island Express Helicopters, Inc. Number 3, participate in the Federal Aviation Administration's Safety Management System Voluntary Program. And number 4, install flight data recording devices capable of supporting a flight data monitoring, FDM, program on each helicopter in your fleet, and establish an FDM program that reviews all available data resources to identify deviations from established norms and procedures, as well as other potential safety issues. There are 3 previously issued recommendations reiterated in this report. 2 to the Federal Aviation Administration, A1635, which reads, after the action and safety recommendation A1634 is completed, require all 14 Code of Federal Regulations, Part 135 operators to establish a structured flight data monitoring program that reviews all available data sources to identify deviations from established norms and procedures and other potential safety issues. And A1636, require all 14 Code of Federal Regulations, Part 135 operators to establish safety management system programs. And 1 to Airbus Helicopters, Bell, Leonardo Helicopter Division, MD Helicopters, Robinson Helicopter Company, and Sikorsky, a Lockheed Martin company, which is A2029, provide on your existing turbine-powered helicopters that are not equipped with a flight data recorder or a cockpit voice recorder, a means to install a crash-resistant flight recorder system that records cockpit audio and images with a view of the cockpit environment to include as much of the outside view as possible in parametric data per aircraft and system installation, all as specified in Technical Standard Order C-197, Information Collection and Monitoring Systems. The recorder system installation should be considered essential equipment that remains installed for the life of the helicopter and have provisions to ensure it remains operational during each flight. There are 2 recommendations classified and reiterated in this report, both to the Federal Aviation Administration. First, A1634, require all 14 Code of Federal Regulations, Part 135 operators to install flight data recording devices capable of supporting a flight data monitoring program. This recommendation is classified open, unacceptable response. And secondly, A1313, require all existing turbine-powered, non-experimental, non-restricted category aircraft that are not equipped with a flight data recorder or cockpit voice recorder and are operating under 14 Code of Federal Regulations, Parts 91, 121, or 135 to be retrofitted with a crash-resistant flight recorder system. The crash-resistant flight recorder system should record cockpit audio and images with a view of the cockpit environment to include as much of the outside view as possible, and parametric data per aircraft and system installation, all as specified in Technical Standard Order C-197, Information Collection and Monitoring Systems. This recommendation is classified open, unacceptable response. Chairman.
Okay, Mr. Curtis, thank you very much. Is there a motion to adopt the recommendations as presented?
I so move.
Okay, Member Chapman, I hear you as moving that, and is there a second?
Second.
Member Hamady has seconded. It's been moved and seconded to adopt the recommendations as presented. Is there any discussion? I should say, yes, I'm sorry, I didn't ask if there were any amendments, but I don't see any proposed amendments. It's been moved and seconded to adopt the recommendations as presented. Is there any discussion? Seeing none, we'll proceed to a roll call vote. Vice Chairman Landsberg.
Vice Chairman votes aye.
Vice Chairman votes aye. Member Hamady.
Aye.
Member Hamady votes aye. Member Graham.
Aye.
Member Graham votes aye. Member Chapman.
Aye.
Member Chapman votes aye. Chairman votes aye. The safety recommendations have been adopted as presented. We now turn to that point in the report where we would adopt the final report. However, I believe that Member Hamady may have an amendment or two for the report itself, the main body of the report.
Yeah, I have one amendment, and it's the second amendment that I circulated yesterday, amending page 18. I suggest adding it to the end of line 5 or 6, but I'd like to offer this amendment with the allowance for staff to determine where in this section is the best place to put it based on their decision making. So my amendment is to add the accident helicopter was initially equipped with a Fairchild A100 cockpit voice recorder when it was delivered from Sikorsky to the initial operator. It was subsequently removed by Island Express as permitted by FAA regulation. I have regulations, take off the S, comma, during the interior modifications.
Okay, there's Member Hamady's motion. Is there a second?
Second.
It's been seconded by Member Graham. Member Hamady, I recognize you.
Thank you. This is the factual part of the report, and I think since we are emphasizing the importance of CVRs, I wanted to make sure that I highlighted something that was also actually pointed out by Sikorsky in a submission to NTSB as part of this accident investigation, which notified us that the accident helicopter had been initially manufactured with the cockpit voice recorder inside, but that had been removed by Island Express when they modified the helicopter to accommodate more passengers. You're on mute.
Any comments, questions, discussion from the board before we turn to staff's comments? Okay, seeing none, we'd like to get the position of our staff, please.
Thank you,
Staff
Chairman.
concurs. Oh, sorry. Yes, staff concurs, Mr. Chairman.
Okay, I heard Mr. English say staff concurs, and Dana, I think you were speaking as well, Ms. Schultz.
Yes, Chairman. It's factual information that's factually accurate, so we support this.
Okay, thank you. Thank you for that. It's been moved and seconded to adopt. Yes, sir, Michael Graham.
Yeah, and I just want to say I support this because I think it just goes in line with our recommendation A20-29 also, which reads at the end and reminds you again, the recorder system installation should be considered essential equipment that remains installed for the life of the helicopter. I think this just goes in hand with that, so I would support it. Thank you.
Yeah, I think it's a good addition, and we don't know why Island Express removed it, do we, Mr. English?
Yes, we do. It was March 16th of 2016.
Yeah, the question is, why did they remove it?
Oh, why? It's when they're not required by regulations, operators typically remove them as weight and maintenance savings.
And when the previous owner had the helicopter, there were actually two previous owners before Island Express having it. They kept it in. Is that correct?
Yeah, yes. For most operations, it would have not been necessary after the installation of the SPC 7000 autopilot, but the previous operators did leave it in.
Yeah, so two previous operators left it in. Island Express took it out. Okay, any other discussion? Thank you. It's been moved and seconded to adopt Member Homendy's language, addition to the language in the report to be inserted at the appropriate place in the report. No further discussion? Seeing no further discussion, we'll proceed to the vote. Member Landsberg, Vice Chairman Landsberg.
Vice Chairman votes aye.
Vice Chairman Landsberg votes aye. Member Homendy.
Aye.
Member Homendy votes aye. Member Graham.
Aye.
Member Graham votes aye. Member Chapman.
Aye.
Member Chapman votes aye. The chairman votes aye. The motion carries unanimously. Are there any other issues related to this report that our board members would like to discuss? Okay, do I have a motion to adopt the report as revised?
So moved.
Vice Chairman moves. Is there a second?
Second.
Member Chapman seconds. Any further discussion? It's been moved and seconded to adopt the report as revised. No further discussion. So Vice Chairman Landsberg, your vote is?
Aye.
Vice Chairman votes aye. Member Homendy.
Aye.
Member Homendy votes aye. Member Graham.
Aye.
Member Graham votes aye. Member Chapman.
Aye.
Member Chapman votes aye. The chairman votes aye. The report has been adopted as revised unanimously. Do any of my colleagues wish the right to file a concurring or dissenting statement?
I reserve the right.
I will reserve the right as well. As we prepare to wrap up the meeting, those participating in the board meeting may feel free to turn off their cameras and mics. In closing, I want to thank my colleagues on the board for their preparation going into the board meeting and for the good discussion and the good debate. My special thanks to Member Homendy, who is the board member on scene, and to Member Chapman, who as a new board member at the time, he launched to this accident in his training capacity. Thanks to the investigative staff of the Office of Aviation Safety, as well as that of the Office of Research of Engineering. But I always say that nothing at the board gets done with just one person. It truly is a group effort and a sincere effort, a sincere thank you, not only to those who worked on the investigation, but to the program and the support staff members, and certainly to those who worked on the report, program and staff who helped bring this board meeting together, and to our IT staff and managing director staff and AD staff to pull it all together for a board meeting. The recommendations that we issued today, the newly issued recommendations, if acted upon, will strengthen aeronautical decision-making skills related to weather for Part 135 helicopter pilots, and it would result in research on spatial disorientation simulator training devices. The recommendations that we reiterated and those that we reclassified and reiterated, if acted upon, would result in safety management systems and flight data monitoring throughout the Part 135 aviation community, including installation of devices that would make flight data monitoring programs possible. And they would also result, these recommendations would also result in crash-hardened recorders with inward and outward facing image recorders on board most flights, including on-demand Part 135 flights. Action on the recommendations issued today will move us forward now. action on the reiterated recommendations is long overdue. We stand adjourned.